Sorry, good morning to everybody. I'm so happy to be here on the InterPartner. I hope you can see my presentation because I have no access to this. So it's my privilege to be the keynote speaker on the InterPartner conference. It's my fifth time. And so I regret a lot that I have no ability to be with you in Odessa. I hope it will be possible in near future because that's something which makes us troubled. From the other side, the cooperation between the universities and us during this last time since the previous conference confirmed that science bring us together. So I proposed the title of the presentation as follows: Unlocking Industry 4.0 and the Digital Single Market, Navigating Digital Transformation Map. That's a very critical issue nowadays all around the Europe. It's, I think, also extremely interested for the Ukrainian partners because we should prepare yourself what will be after the war, what we should do to support the economy, the society, how to develop the country. So let me say there are some initial statements about what is the digital transformation. It's worth to note that we shouldn't mess it with the digitization. It's the process of just transforming information into a digital format. Sometimes we call about it dataization. So we are talking about replacing non-digital manual processes with the digital processes, or just replacing old technology, which is truly digital. We are living in 21st century, but it requires, according to the achievements of the technology, it requires a replacement to have a better efficiency or more capabilities. What is the digital single market? Digital single market is something formal which was introduced by the European Commission in 2015. And in 2021, just during the COVID pandemic, the European Commission created a document which was named 2014 Digital Compass. And due to this document, I want you to emphasize some statements about the digital transformation of business. So when we are talking about the manufacturing, the European Commission put a point of the gravity into the business model, which is called manufacturing as a service. When we talk about the technological solutions which will be available or should be available for the decision support processes and decision making, the vision strongly present the artificial intelligence. If you remember 23 years ago and now our perspective on artificial intelligence, it's visible that this field of the research and first of all implementations cross the critical level of the diffusion. I think we are now in very interesting moment of applying artificial intelligence. What we still ahead us, but very next corner is the quantum computers. We strongly believe that quantum computers give us a real power of the algorithms which stands behind the artificial intelligence. And finally, there are some things which are not confirmed after those 2 years. I mean, idea of the zero stocks are not really. It should be updated. We believe that the era of the global supply chain, which is uninterruptible, is not really words of trust. We observe it also in Poland. The companies starting to create some stocks to preserve the materials for the manufacturing. So there are, of course, some other aspects and issues like the cloud computing and the digital intensity, which is, as you can see, very optimistic on the level 90% respectively and 75%. According to the documents of the European Union Commission, 2 years ago, the gap due to the current state, current performance, and the target which was stated is significantly visible. In average, we are just in the half of the way 2 years ago, but it's still a lot of the things to do. Another actual data are about digital economy and society index, and they are taken from the KPMG report 2022. And unfortunately, I think because of the obvious situation in Ukraine, there was no possibility to find a real data on Ukraine. So I strongly believe that Ukraine is somewhere there. We are just here as a Poland, so you can see that generally average European Union is here. The first position, the pole position, is for Finland. For many years, we know it. I appreciate personally very much the position of Slovakia, which is just before us. So that's the current state. When we finally look at the current data in Poland, which we can take from the report which is issued every year, the Business Digital Transformation Monitor, and it's prepared by the KPMG company and Microsoft. That's the real situation here in Poland. We are still below the half marks of the scoreboard. There is a lot of things to do. Finally, when we just the simple monitoring is based on money. Money talks. So 29% of companies do not allocate funds for the digital transformation. So not bad, but 71% assign no employees to task in this area. It's much more trouble task. So it's not only the question of the money, but that's the question of finding, employing, or improving human resources and people which can be leaders in targeting these ideas about the digitalization. There are, of course, some approaches which we can present about what is important in digital transformation. So that's known ideas. There's one of them. We started with the technology. We employ the data science to have a better inside view of the phenomena which happens around us. And this knowledge is based on collected data, massive collected data. We talk sometimes the big data as an approach to analyze the processes due to storage, massive storage of the data. But when it comes to the operations, the very important part is the processes, people, and culture, what we mentioned earlier. And there is no way to transform unless you have successfully altered employees' behavior and reorganize the structure of the management in the company. Specifically, I mean flattening, not building the big hierarchy, the vertical hierarchy, but flattening the structures. So we have the new ways of doing things as a final stage in this process. Of course, it's a dynamic process with the feedback, which give us an ability to changing the approach for collecting the data and analyzing, etc., etc. So what is interconnection, or where is the Industry 4.0 in this big picture? So that's one of the models which I personally like very much. This model give us a 6-stage process which is based on values, which we can take away from each stage during the process of implementation. So when we are talking now about in which point we are now, I think we are just between the visibility and transparency. There is a very few companies which use the predictive capacity of the technology and trying to find the answer, what will happen. Specifically, it's not implemented, I think, in industry. Some of the aspects of the manufacturing operational processes, like maintenance of the machines and looking for the high accepted risk of failure of the machine. We have some first system which are using artificial intelligence to making a prognosis which help us in this. But the self-optimizing environment of the machines is still ahead of, is the process of adaptability. And the generic methodology is always simple. We are talking now today about this because there is a growing number of the funding programs also in Poland, which I took part in now, preparing the applications, which are based on this generic model. We should prepare something like digital roadmap for the company. So there are 3 main phases of this process. First, we collect, during the process of audit, we collect the data about the goals, about the priorities of the company, and finally we should have inside knowledge about implemented technology and system. The next step, we create a methodological analysis, which is grounded in the targets, benefits, which are prioritized by the management of the company. We are matching it with the knowing capabilities and finding the missing capabilities due to the current. And finally, we create something we can call the gap analysis, which is verified in the process of consulting with the company. And the next step is creating, I think, 3 years medium time horizon strategy, how the company can put actual investment into the bigger picture. What is the paths of development for the next 3, maybe 4 years? I think 3 years is enough. Everything what we can predict before this moment in time is just simple. We know nothing about it, especially in the times we live in. So the methodology we used actually is the results of the European Commission program, which was finished in 2018, and it was about creating a generic tool for the companies, which will be free of use, to make them possible self-scanning of their maturity or digital readiness of the enterprise. Of course, it's based on these previous presented generic models of scanning the capabilities, processes in the structured way, and looking for the gaps, which makes a foundation for the next step, creating the transformation strategy. So that's a process in every country involved some organization, also in Poland. So there is not only available in English, but it also in any European countries' languages because of the activity of the local business organization or consulting companies which are working in this area. And the self-assessment with the ADMA model is officially put it in the conditions of application in current period of applying for financing some part of the transformation, because it's not fully in Poland. It's about, I think 70% is in current approach is financed by the government money. The 30% should be preserved by the company. So the ADMA methodology is just like this generic, but what is more interesting, or how it is going on in the company. So there is 7 axes or dimensions of the analysis of the capabilities and current state of digitalization, and we can group them into 2 sets. The first one is everything what is about non-technological transformations. We strongly believe that digital transformation and Industry 4.0 is not possible to implement without skilled and educated people, as well as well-developed management systems and up-to-date support of the decision makers with the sources of the information, both the internal and external nature, when we talk about the organization as the system. So that's the eco factory, that's the aspects of the ecological production, that's the human-centered organization. For instance, what is the nature of the communication between the staff and the managements? Are there any barriers or something like that? So in the context of the innovative culture of the organization. The another is value chain oriented open factory. That's the idea about interconnectivity. And when it comes to the second set of the dimensions, it's of course about advanced manufacturing technologies, digitalization, the flow of the data on every level of the management, starting from the operational level, the workshop floor, to the strategic level in the company, end-to-end customer focused engineering. It's mainly this idea based on the mass customization processes, which we know very well since 90s of the previous century when it was introduced to the manufacturing. And finally, the smart manufacturing. So the idea, which we also discussed many times in last years, it's about how to implement the Internet of Things, the online communication with the machines, the digitalization of the technological marshroot, etc., etc. And finally, when we create something like the spider diagram, which give us a general overview of the actual situation in the company and the we can see the potential gaps which we can make an issue to solve. So there are some specific problems with this. First of all, when you do a scan of the company, that's the blue line, and we can see that's very similar to the last scans I did in some of the companies. It's not symmetrical, that's obvious, because every branch, that's the problem, every branch has a specific pattern of the digitalization, in my opinion. That's the big trouble, because we started with the statement that that's the self-assessment. It's a self-diagnosis. I think that's the better. And this diagnosis is not based on the idea that higher than better in every case. In some cases, yes, but in some branches, in some companies, it's not really necessary. Specifically, there are some also conditions which are visible during the audit in the company. They don't need it. And the fact that they are on one of the dimensions, they are lower than on the others, and they are lower than the just between the start and end of the scale, it means nothing. When you can, I think, nothing wrong. You should include into analysis the specific of this company, the specific of the branch. Another story is what is the factor of the future benchmark. So that's the question: how to have the access to the average results on the branch for any branch to compare your company with the some general picture. That's why it's so interesting that we are doing those, we are filling those questionnaires online to support the growing number of the company which use the system on the national level to feed them with the data, and in the end have not only the answer about when I am just on the scale, but what are the similarities, or what is just simple the benchmarking. I want to have a benchmarking to the other companies. And finally, that's the question about factor of the future benchmark. That's something which is mostly theoretically stated. So just in the practice of analyzing, the consultants use the level 4. So they believe that generally we can say that the company became digitalized in a significant, I think, way when we cross the 4 point of the scoreboard on any axis. Of course, it's digitized in one of the aspects. So this is the simple model. It is the standardized model. It also good that it was assumed that, okay, we have a lot of the models and many companies and researchers create own models, but it's good to have a measurement instrument which we can use for comparing the results from the different countries, different regions, different branches, etc. And that's the big value of this approach, which was introduced and implemented in practice. And finally, I want to thank you once again for the invitation. I want to give you words of support for your efforts to continue with the research and teaching. We are just ahead of starting of academic year. I truly believe that we meet together soon. This picture was taken just 2 years ago. You can see those pictures. I personally thank you very much, Professor Vladimir Tonkonogi, and Vitaly Ivanov for inviting me once again to take specifically this year very strong position in the conference. I am the first speaker. Thank you very much. I appreciate it very much. My hearts are with you. I hope that in the near future we can meet in Ukraine, as during the last 1.5 years we cooperate around the Europe, in Poland, in Slovak Republic, in Czech Republic, in Romania. I think that's our front line. We should prepare the students, our staff, keep them just developing the knowledge, finding new connections, to be ready to start Ukrainian economy as well as the European economy after this bad time. Thank you very much again.
Dear Slawomir, thank you very much for your wonderful presentation. You are our star in smart manufacturing in digital.
I hope not falling star. We play a very significant role as a University of Technology here. We developed some ideas in last year to create the Center for Support the Defense and Security issues in Poland. We cooperate with the Rzeszów University of Technology and the Lublin University of Technology, as well as the others. I truly believe that those efforts also support in some way your defense system during this hard time.
Thank you very much. We know that you are a very hard-working person and appreciate your time. Anyway, thank you very much for your strong support of Ukrainian universities, and thank you very much for this wonderful picture.
Slava Ukraini!
Героям слава! Okay, thank you. We wish you a success in your research.
Thank you very much. I will join you afternoon.
Okay, thank you.
Virtually.
Thank you. Dear colleagues, we received a notice that air alarm was announced in Odessa region. So according to our legislation, we need to stop our conference at this moment, and we will continue our conference with the second keynote speech after the cancellation of air alarm. Unfortunately, we have to follow these mandatory safety rules.
professor in Odessa Polytechnic. Будь ласка. The topic of his speech is Intelligent Mechatronic Mechanisms, New Opportunities in Engineering and Technology. Please, Vasily.
I think it's possible to start. We are now in Odessa. You see the subject of my presentation, Mechatronic Technological Systems, a new stage in development. I represent several Odessa organizations. For example, Odessa Polytechnic National University, Odessa Academy, Military Academy, and also Odessa Academy of Architecture, and also Odessa Agrarian University. Next slide, please. This is our creative research team. For example, Anatoly Gushin, associate professor, now Anatoly Gushin. Here, I would like to introduce you to him. Anatoly Gushin. Other members of our creative team are military. For example, Colonel Alexander Lysy, associate professor, senior lecturer Vladimir Marchenko, also Odessa Military Academy. Several members are civils, for example, Alexander Limarenko and Alina Tselikova, also associate professor. Next slide, please. Oh, I forget. Honor member of our team is Michael Böhm, managing director from Germany. Next slide. This is introduction and major challenges. Intelligent mechatronic mechanisms designed for mechanical cutting of materials with exclusive physical and mechanical properties. They have passed the stage of formation, you see, and they have proven the positive qualities and new capabilities as a part of a new generation mechatronic technological system. This applies to mechatronic technological machines and equipment. For example, for machining, I mean machine tools, transport, I mean cars and trucks, medicine, for example, orthopedics and dentistry, as well as military. For example, air defense, it's now in Odessa dangerous conditions. We are working under air defense. Then aviation, space, and other equipment. What are the features of our mechanism as a response to the major challenges? You see, property of adapting to unpredictably changing conditions without feedback sensors, multi-level control of complex object, that is property to suspend top-level control and takeover control, responding to emergent disturbances by changing their configuration, and the last, processing digital analog information simultaneously to create a corrective action. On the right, you can see the photo. It will be later discussion. Next slide. This is our aim and research tasks. Our aim of this presentation is to familiarize the scientific community with the created intelligent mechatronic mechanism, which firstly are configuring taking into account the force counteraction of the control object, and secondly, have the property to eliminate emergent disturbances, control by disturbances. This is the name, control by disturbances. What is the means to finish or to go to the end? It means to the end, this is a practice of developing mechatronic technological systems, for example, electroerosion, electrochemistry, machining, milling, grinding, etc., since 1972. At that time, the new science was born. The name of the science is mechatronics. Mechatronics includes mechanics, informatics, and also electronics. For example, electricity and magnetism. The picture on the right, it will be later. Next slide. Our research task, the first, implement in practice the control method by disturbance for a wide range of hard-to-machine materials. Second, theoretically and experimentally substantiate the principle of compensation of disturbances by the control-configured mechatronic mechanism. Third, develop mathematical equations for the process of action and reaction, inside IMM. Fourth, provide the possibility of adaptive and intelligent control of machine, not only for machine tools, but also for other technological machines and equipment, including vehicles, cars, tracks, medicine equipment, for example, orthopedics, dentistry, etc. And the last, form the basic principles of creating a new generation of IMMS. Next. This is research methodology based on the well-known physical phenomenon for IMM operation, the so-called Ampere's force of electrodynamic force. You can see the equation and you can see the parameters of the equation. For example, F is the force vector, I is the current stress, B is the magnetic flux density or magnetic field induction vector. On the right, you can see resultant field for a current carrying conductor and initial inductions B1 and B2. Next. Next slide shows 4 technological principles of methodology. Technology, this is the first. This is our principle. You can see 4 technological principles. The first, interventions in the machining process should begin at the pre-production stage. In this case, it will be a control based on initial empirical data. Second, possible deviation during the machining process, for example, cutting torque increment, must be used as a deviation signal for a high-level system, for example, CNC level. This signal is also used for direct control by disturbance. So it applied to machining the force parameters, that is, cutting force and torque, must be included in the IMM servo system as an independent ones, just like speed or displacement are independent parameters in a conventional CNC system. And fourth, intelligent control over the machining process must be carried out according to many parameters, as science and science, including indirect science that precede the occurrence of undesirable phenomena in the cutting zone. For example, increasing noise, vibration, temperature, etc. Next. This is the so-called control by disturbance versus control by deviations. There are 2 principles of automatic control, and you can see both of them. 2 possible, the first, the use of IMM as a force converter for adaptive control without the CNC. That is, IMM are used directly for automatic control by disturbance. Second principle, the use of IMM as an information transducer. IMM detects a deviation, for example, based on the current position of the IMM working body or tool, while a CNC system of a machine eliminates the deviation by the appropriate fit selection. This is the end of the 11. This is the we are continuing. The scheme on the left and the scheme on the right shows you 2 main principles of automatic control. Next. Next. This is the so-called hierarchical control. And this is two-level control, technological idea as a basic step. On the right, you can see the scheme, and on the left, in the control system development, at the upper level of control, a more significant but less accurate decision is made based on empirical data. Therefore, it will be some kind of formal decision. Second, on the contrary, a robust control system on the lower control level takes into account the machining actual conditions. Sometimes it will be with the help of the so-called research development test laboratory. This is enough. Next. This is well-known technological cycle of any machine. For example, drilling and so on. The cycle characterizes the main states. What are the main states of any machine? The first, equilibrium, A. Rapid approach, B. Machining pass, C. You see C. And rapid retraction, D. Thus, the working body performs the same repetitive movements. You see on the right of this picture, you see standard technological cycle. So the next. This is modeling of oppositely directed acting forces. Reciprocating moments are provided by the joint action of the forces. You see these forces: Q, F, electrodynamic, F, electromagnetic, and F with index Z, the so-called axial cutting force. Moreover, Q is equal to mg. No, G is a free fall acceleration. The first main force is electromagnetic force. You can see F with index m in newtons. This force is created by the coil with the current, the so-called solenoid, can be found by the equation. Equation you can see as a product of three quantities. For example, coefficient, B, magnetic induction, S, cross-sectional area, and this is enough. And the main second force is electrodynamic force, F with index ED. In newtons also is acting on a current carrying conductor of length L. In magnetic field with induction B can be found based on the well-known dependence for the ampere force. You see the equation F with index ED, that is electrodynamic force, is equal to product of of four quantities: coefficient, B, magnetic induction, I, electric current, and L, the length of the conductor. Next. This is creating axial cutting force through the so-called ball coupling. Ball coupling. This is special mechanism invented by Professor Bushin, Anatoly Mikhailovich. The sensitive element of this mechanism is part of the IMM. It may be a source of information. This might be possible to use this sensitive element to control the technological process according to its power parameters. A figure. By comparing the torques on the input and output shafts of the coupling according to the schemes B and C. You see the construction, you see output shaft, you see input shaft, you see delta S. This is the scheme for calculation. Next slide shows coupling conversion into power and sensing elements. There are two nodes. First, power element, force converter, and sensing element, information transducer. You will see the construction, two positions after the shift, A and B, and before the shift, C and D. You see also designations are, for example, R, you see, is the radius of the rolling cycle of the balls. Delta P is the shift in the angle of rotation of one coupling half relative to the other. For example, delta L is the length of the arc, and delta T. This is enough. Next, please. This is continuation. Sensitive element description, or the ball coupling. You see scheme and several equations. For example, equation number 1. You see delta L is equal to fraction in the numerator is PR delta T divided by 180 degrees. From the triangle ABC, you see ABC is equal to the equations, and you see delta S divided by delta P is equal to fraction numerator PR, denominator 180 multiplied by tangent alpha. That is enough. Next slide. Mechatronic module with a calm coupling. Calm coupling, this is the second mechanism invented by Professor Buchin. You see some elements of this construction. For example, 1, this is base. 5 and 6, field winding, the main, one of the main winding, field winding. 7, non-ferromagnetic armature. Non-ferromagnetic armature, moving armature coil. For example, 8 is the armature winding. There are 2 windings in the mechanism. Field winding, 5 and 6, and armature windings, 8. Next slide. This is the continuation of this construction. You see the scheme, you see the ball bearing 2 pieces, ball bearing 1 position, ball bearing another position, delta S. Delta S, this is the value to control, is equal to, on the left, delta S minimum, and on the right, delta S maximum. Next. This is a new stage of development of our constructions. This is a so-called mechatronic module with a ball bearing screw converter. You see idea A, you see embodiment B, ball bearing screw converter. You see also ball bearing screw. A, idea, B, embodiment. General construction, you see on the right. Next. This is our results. You see IMM biased mechatronic machines produced by Professor Buchin. For example, walking zone, IMM spindle, you see PC, personal computer, conventional spindle A, this is conventional standard spindle, and experimental one invented by Professor Buchin. The following principles were used in the development of IMM. First, elimination of the rigid connection between the total rotation frequencies and its axial feed. Second, separation of the process power parameters. For example, when drilling, this is separation of the axial force and the cutting torque. Next. This is result and experiments results. You can see experiment stand for example, for studying the linear motor characteristics. And on the right, you can see the picture of this, about these characteristics. You see workspace on the left and on the right. On the left, delta x is changing parameter. On the right is the so-called electric current, field electric current, or electric current for field winding. The next. Verification of the theoretical relationship. You see several equations. You see the dependence force on the alpha. Alpha is the angle of inclination, helix inclination. Helix inclination, you see picture B. Recommendations. Equation 3 shows that delta t is equal to 0 when alpha equals 0. Delta t is equal 1/2 of t when alpha is equal to 45 degrees, and delta t is t at alpha when alpha is equal to 90 degrees. Next slide shows the hand of Professor Bush under grinding wheel. This is example of the so-called nanotechnology. This is zero force grinding the hand of the iron crater. On the right, you can see takeover control example. A, B, C. A before, B during, and C after the occurrence of the disturbance. Also, you see the disturbance designated by letter D. Next slide. This is our products produced by our equipment. The IMM biased mechatronic technological systems, ZSMTS, makes it possible to machine materials of any hardness, from low hardness materials, for example, bone on the left, passing through materials with medium hardness, for example, optical glass at the center, and ending with super hard materials, for example, lacquer sapphire and ruby. No, this is our machine tool, the IMM biased mechatronic technological system. Next. This is the work of our partner from Germany, Michael Dawn, courtesy of Uber Records GmbH, Germany. This is construction, and this, on the right you see you see specifications of this construction. For example, machining type drilling, milling, motor type asynchronous or synchronous machines, tool holder, maximum speed, weight, maximum frequency, and so on. Motor spindle features. For example, limitation, adaptive control. Limitation and control of the drilling torque M with index Z, axial force control, force F with index Z, in the range between 5 to 70 newtons. So also you can see tool diameter from D1 to D6 millimeter, spindle cooling. This is enough. Next. This is the system, the spindle control system for grinding and drilling. You see PC with special programs, programmable laboratory source, power supply for amateur coil control, inductive position sensor, measuring cup. On the right, you see experimental stand for the spindle research. Next. Slide shows cutting force measurement in tangential drilling. For example, you see dynamometer, signal amplifier, DAC system, PC, general view for experimental stand, the IMM spindle research and drilling. On the right, it's the picture you have seen before at the beginning of my presentation. Next slide. This is experimental results for determining thrust and torque control. You see the machine, you see the dependence for thrust F with index Z and dependence for torque with index Z. This picture characterizes control from our control system in connected with technological requirements. That is by varying stator current, by varying stator current. Next, this is weighing forms for the different cases of experimental work. This is polymer composite material with 7 layers. The stator winding maximum current is 9 amperes. The amateur winding direct current is 10 amperes. The tool diameter is 2 millimeter. Power converter helix inclination. First case, 21, more than 21 degrees. And second case, more than 38 degrees. B, A and B. Next slide shows the new technological possibilities. At the center, you see the free hole exit with IMM, by means of IMM. Below, you see exit hole with burst. This is bad without our IMM. On the left, you can see the picture you have seen before. And on the right, this is drilling of aluminum porous plate with IMM. Next, this is our conclusions. For the future, the first conclusion is the working movement in a technological machine is the result of an imbalance of opposing forces. This allows creating a classic reciprocating cycle of machining. Second, intelligent principles in mechatronic technological systems based on IMM. The following. The first, the hierarchical multi-level control principle. Second, the property of lower level system to suspend control from a high level system. And the third, the self-learning and self-preservation principles, as an instinct in living nature. So, intelligent mechatronic mechanism is a control configured one. Both two functions of the IMM sensitive element, both a source of information, that is sensor, and the converter of information into a force action. And the last, the principle of control by disturbance, or disturbance compensation principle, when the speed of response to disturbances approaches the speed of action of disturbances. This is enough. This is our conclusion. Next. Acknowledgement. Our creative team, gratitude to their affiliated organization for the opportunity to perform complex research work in the development of mechatronic technological systems. Organization, UC, Odessa Polytechnic National University, Odessa Military Academy, Odessa State Academy of Civil Engineering and Architecture, Ukraine. Odessa State Agrarian University. And now our honor partner, Yoga Rackets GmbH, Germany. The authors, that is we, invite enterprises and organizations both in Ukraine and abroad to cooperate in this area. More detailed proposals and videos for cooperation can be received at the following address. And the last slide shows contact information. Vasily Larchin, Odessa Polytechnic National University, Odessa Military Academy, and my email address. Thank you for your attention, and I am ready to answer your questions.
Thank you very much for your interesting speech. Maybe some questions from participants. Oh, Professor Anisko.
Thank you for your interesting presentation, but I have one question to you. Pan Vasily, can you explain us once more about how many different elements as forces can you do it can you apply your new mechanism and your system? For example, I mean in this system force about force of cutting or any kind of force. Answer, please.
Our mechanism is made for stabilization, cutting forces, and cutting torques with the help of adaptive control and with the help of intelligent control. This is main task, important task for the technology, because conventional CNC system stabilizes not forces parameters, but kinematics parameters. Kinematics, for example, velocity, speed, displacement. This is kinematic parameters. But our mechanism take into account force parameters, cutting force, as you said, and cutting torque. This is the sign of technology. This is the first aim for our team, technology, and then it will be equipment. Technology and then equipment as a means for this technology.
Thanks.
More questions? Professor Ivanov.
In manufacturing process, the torque is rise unexpectedly, rise rapidly. What difference in behavior you invent and conventional driving machine?
Difference between conventional and our.
Yes.
And our. Different what I said, and once again, I'm saying that difference is in conventional system. This is kinematic parameters, speed, displacement, acceleration, but not force parameters, not force, cutting torque. In technology, cutting force and cutting torque, this is the main factors to produce quality parts without defects. That is why our machine stabilizes forces parameters. That is the so-called adaptive control of forces parameters, cutting force and cutting torque. This is the difference of our machine from the others.
Sorry, what's the way? What's the way? Too slowly rotation or too slowly movement, actual movement? What's the way to control torque? If torque arises from the manufacturing process?
Short answer.
Once again, our distinctive, our difference from the conventional, this is stabilizing the force parameters, not kinematic, but force. This is the reason of technological defects. To eliminate technological effects, it's necessary to control by force parameters, cutting force and cutting torque. Cutting force and cutting torque. Thank you.
Oh, Professor Tikhenko.
In first construction mechatronic machine, we can see axial displacement delta S.
Delta S.
Is it possible precision machining with this mechatronic machine? Precision.
Delta S, this is parameters of our mechanism to control the in two directions. First directions, control by disturbance by means of our mechanism, and second direction, control by deviation by means of CNC device. Delta S has two main functions. Delta S is force parameters, one, and delta S is transducer for the system of high level. For the system high level, this is CNC system. Delta S is our main sensitive element. This is the base for intelligent control.
Oh, I'm sorry. Last question. Okay.
In your structural schemas of controlling process with negative feedback.
With negative feedback.
For this,
Speak loudly.
this mechatronic system with spindle motor, what was the controlling type or controlling law? Like it was proportional, integral, differential, or combined?
There are several well-known control kinds, proportional, integral, differential. This is, it does not matter for this presentation. It does not, we well know these principles of construction, of control systems. The main task of my presentation is to show you that we can control both by disturbance and both by deviation with the help of user principles. So this is the main task to show you two main control principles, by disturbance and by deviation. By deviation with feedback, as you said, this is standard approach as in our work. Standard. This is not the question of my presentation. That is all. That is all.
Dear Professor, congratulations on interesting report, and I give you certificate of recognition for your work as keynote speaker.
Thank you very much. Thank you.
Thank you. We have finished the keynote session. Now there is a short break, about 5 minutes, and we will start the second session, which we will chair Professor Oleh Niska from Ivano-Frankivsk. Only 5 minutes.
Today, our section number 2, we call that the manufacturing processes. We have 5 presentations of this section. In this presentation, we have a lot of foreign co-authors from Poland, Lithuania, from Serbia, and from Turkey, and from Italy. Now we have presentation number 1, and our young researcher Katerina Kirkopoulou presents his I hope, very interesting research. Please, you have 15 minutes. Start, please.
Thank you. I'm glad to welcome all participants of the conference. I'm really happy to be here. It's a big honor for me. I'm really a little bit nervous, but I try to be effective and not to be boring. I will continue the topic of defects and their corrections, and our work is design of an operator interface for controlling the installation of ion plasma deposition. Introduction and major challenges. Adapting to new realities through interface modification is important to minimize defective products and improve ion plasma coating efficiency. It's connected with HMI for process automation system standard. And to summarize the main aim of the work, we try to create some interface for our installation. Aim and research task. The study aimed to develop an effective interface for ion plasma installations, aligning with the standard and accommodating high automation. Objectives include integrating automated control with interface design, optimizing human-machine interaction, ensuring robust signal transmission, and enhancing dynamic process visualization and recipe systems. Research methodology. To solve this task of developing an effective human-machine interface, a comprehensive approach is proposed. Such an approach includes an analysis of the technological process of ion plasma spraying installation operation, determination of the requirements and features of the technical implementation of the control system, formulation of requirements for the human-machine interface for interaction between the operator and the ion plasma spraying installation. The main stage of the operation of the ion plasma facility. The main problem of technical measurements in the technological process of ion plasma sputtering is the problem of temperature measurement. Temperature control is critically important because violation of the temperature regime affects the adhesion between the coating and the tool, which leads to a critical decrease in the micro-hardness and stability of the tool. This figure show you the stage of operation of the Bulat setup facility and required control systems to ensure the quality of their implementation. This stage you can see. Requirements and features of the technical implementation of the automated process control system corresponds to the following classification. The system belongs to the lower level of the hierarchy of possible management. Management is carried out by a continuous discrete technological process of medium reliability where the automated process control system stops in case of failure. Of small information capacity where the number of information channels does not exceed 40 units. The level of automated computer control of the automation system includes the following software: OPC server, management service, the database server stores, the recipe editor allows editing and creating new recipes, SCADA, simulation software, connecting sensor and actuators to the control device can now be done with either a separate wire or an industrial sensor network. Next one, installation of ion plasma spraying can operate practically in automated mode. However, the loading and unloading process of the tool, recipe selection for work, and setup of the installation are performed by the operator. Since the task is to control a single industrial unit with constant operator intervention and the possibility of detecting the need for modification of the control system software algorithms, it is appropriate to use an industrial computer with a touch screen and a touch network interface as a control device. To ensure reliable computer control of the technological process, it is necessary to use a hard real-time operating system. The next one, on the main, one of the main functions of SCADA is the development of a human-machine interface and a tool for creating it. The development speed is the main indicator of SCADA's property from the system integrator's point of view. The development process includes the following operations. First one, creation of a graphical interface, schematics, graphs, tables, elements for entering operator commands, etc. Programming and debugging of automation system operation algorithms, setting up the communication system with automation system devices, creating databases and connecting SCADA to them. We are really quick. Go to results. From the review, let us highlight the problems that relate to common computer interfaces for ion plasma devices. The main screen displays a diagram with a multitude of digital parameters that do not allow assessing the dynamic and predicting the course of the process. A multitude of distracting factors are used, such as excessive color design, 3D shadows, and animation. The organization of screen is oriented towards presenting information of different types and is not a result of analyzing typical operator actions and tasks that they must constantly solve. The component base and digital alphabet of the interface are not sufficiently justified, which does not allow effectively directing the operator's attention. Some details for all of this. Using visual representation of screens in accordance with the recommendation of the standard, a light gray background is used. Second, a simplified schematic diagram of the installation is used with the use of dark gray lines. The yellow color is assigned to pre-alarm signaling, while red is assigned to alarm signaling. Operators' actions should be confirmed. Second, in our plan, achieving situational awareness. First, the main parameters are displayed in trends with dashed lines of dark green color, indicating the permissible boundaries of the parameters, allowing the operator to forecast the process flow. The trend, second one, the trend is displayed for a rational interval of the process, in this case 10 minutes, rather than for the entire process, enabling the operator to assess the situation. Third, the progress of the current stage of the process, can be assessed using a bar indicator. Third stage in our plan, logically justified organization of screens with a focus on tasks that the operator must solve. 5 screens are allocated: process, reports, recipe, diagnostics, and settings. All screens have 3 mandatory zones: screen switching menu, main zone, message display zone. The process screen is intended for viewing the state of the process flow. Its content dynamically changes depending on the current stage of the technological process. First, using an intuitive and understandable element base of the interface that corresponds to the color alphabet. The color of the simplified process diagram lines and text of its elements is dark gray. Dashed black lines are used to display the connection between control circuit elements. Blue lines with white fill are used to display active interface elements, sensors, actuators, progress slider. The text color of active technological parameters is blue. The text color of parameters that require input is light green. The text color of clickable elements is purple. Conclusion for our work. The analysis of regulations and modern practices in the development of efficient interface allowed formulating requirements for an operator interface that meets modern requirements for ergonomics and situational awareness. The computer interface is implemented in a modern SCADA system. The developed interface allows improving the quality of processing tools and other objects by reducing the amount of defective products caused by operator errors in managing their installation. The obtained results can be applied to the development of new computer system for automation of ion plasma installations. That's all. Thank you for your attention.
Thank you very much. Is anybody who would like to take their questions to our representative? Please, Mr. Yuri. Sit, please.
You mentioned that in the system you have a server, database, and so on. I wanted to ask, does these components have some industrial standards? For example, for medicine and automotive industry, there are special standards for element bases, touch screens, and so on.
Thank you for your question. Actually, we used this standard for process automation system that it might be used for any spheres because it's not really depend with some spheres like medicine or maybe another. Because it's only connected with operator and how he or she works with screens when happens some technological process or another process.
Does anybody else questions to presenter? Please. I have one question about role of SCADA in interface creating process.
Thank you for your question. SCADA is the role of SCADA is imitation model, like not to use some real facility, but to imitate some process like
only imitation, yes?
Yeah, yes.
Thank you. Anybody? Have you questions? Anybody here? Paul, thank you. Thank you, Katerina. Our the next presentations, presentation number 2, Maxim Kunitsin. Are you ready?
start with.
Hello, dear colleagues. As you can see, the report's topic is mathematical modeling of thermomechanical phenomena in mechanical processing of products made of functionally graded materials. Thermomechanical phenomena involved in mechanical processing can result in defects such as cracks, burns, and structural changes on surfaces, adversely impacting the quality and performance of parts and leading to increased processing errors. Mathematical modeling techniques can better understand and control these processes, improving product quality. Maintaining ideal operating conditions is essential to ensure efficient mechanical processing of modern materials. This process involves high heat stress and thermomechanical fields. Mathematical modeling can effectively enhance product quality and performance. The research aims to create a numerical analytical model to determine structurally inhomogeneous materials thermomechanical conditions. This model will consider the presence of inhomogeneities in the facial cracks and inclusions during machining. The ultimate goal of the model is to establish functional relationships between the surface layer quality criteria and the technological control parameters to ensure that the processed surfaces of products have the desired characteristics. Research methodology. We considered thermal and mechanical phenomena during part manufacturing and used in thermoelastic body model to reflect their relationships. To understand the working surface's thermomechanical state, we must consider temperature, stress propagation, and material depths while accounting for inhomogeneities. For further studies of the kinetics of the formation of thermomechanical processes in the processed material, we will use the following system of differential equations as a central theoretical premise describing the interaction of the deformation field and temperature field that can be found on this slide. In order to simplify the heat equation, we have chosen to disregard the conversion of mechanical energy into thermal energy. Additionally, we need to pay more attention to any initial terms and limitations on heat propagation speed and have instead focused on explicit solving the planar problem. We have created a piecewise homogeneous half plane with mutable coatings to model the processed products. We have also taken into account any inclusions and defects such as microcracks that may have an impact on structural inhomogeneities. The equation system used to determine the thermal and stress strain state during the surface processing of parts with coatings that have inhomogeneities like inclusions and cracks compares to main equation of non-stationary thermal conductivity and the equation of Lamé elasticity in displacements. The equation below can serve as initial condition for this task. The boundary conditions for the temperature and deformation fields should consider the heat transfer from the surface outside the contact zone between the tools and the part and the intense heat generation in the processing zone. These conditions can be expressed in the following form like this one. The thermal issue posed by equations that can be found on slides before can be resolved through the applications of Fourier and Laplace transformations to the function of temperature in the initial layer. Additionally, the stress strain state can be determined through the utilization of the method of discounted solutions. To do this, the Lamé equations we prescribed jumps can be constructed using Trapp's functions. By utilizing generalized Fourier transforms for variables x and y, equations on the before slides can provide us with recurrent relations that connect displacements and stresses in the case layer with those in the first layer. It is possible even when faced with non-stationary temperature fields. Uneven heating can cause thermal deformations that result in temperature stresses, which may lead to cracks forming in defects. The stresses intensity coefficients K1 and K2 determine the stresses near the vertices of defects, such as cracks and sharp inclusions. To understand the impact of tool design parameters on the thermomechanical state of the surface layer, we studied the model problem and boundary conditions. Research obtained theoretical and experimental temperatures values to predict the likelihood of defects forming. The study delved into the impact of coating structure heterogeneity on reducing crack resistance. As a result of this research, a model was established to determine the optimal processing of wear-resistant coatings, which included a local fracture criterion. Additionally, this model identifies optimal performance technological parameters for processing defect-free parts with coatings. Results. The technological control parameters will be utilized to ensure that processed surfaces meet the necessary standards. To maintain the quality of the tool, it's essential to ensure that processing temperature, heat flow, stresses, and cutting forces do not exceed their limits. By implementing a system of limiting inequalities in the temperatures values and their propagation depth that represented on this slide, structural changes can be prevented. It can be a foundation for designing processing circles based on thermal criteria. In order to avoid cracks in alloys when rapidly cooled, it's essential to limit stresses. A combination of technological parameters and material properties determines the stress intensity coefficient or heat flow limit. By considering the material structure and adhering to the conditions of defect equilibrium, it is possible to achieve defect-free processing. As an example, the significance of surface roughness in manufacturing fiber optic cables, it elaborates on how the processing quality of tooling working surfaces impacts their performance and the necessary specifications for cable production. Additionally, it touches upon the relationship between the roughness of the die's working area and the defect value in different finishing operations. The main reason leading to the scattering of the light energy in optical fibers is microscopic homogeneities in the material that occur during their manufacturing and the fiber coating interface roughness. Therefore, one of the main requirements for the tool in producing fiber optic cables is the low roughness of its working surfaces, the high geometric accuracy of the calibration part, and compliance with the specific conditions in production. Using the correlation between the roughness of the working area of the die and the defect value in various finishing operations, like as finishing grinding and super finishing grinding, polishing, the stress intensity factor dependence is found on this figure 1. For producing high quality fiber optic cables, it's structural to maintain a specific level of surface roughness on tools through precise grinding and polishing techniques. The roughness should fall between 0.8 1.2 microns. Additionally, mandrel molds and dies must be made from complex alloys with no defect and tolerance that meet the necessary standards. Careful attention should be given to selecting the appropriate technological parameters to prevent the occurrence of micro defects and cracks during machining. It's important to note that current methods of assessing strengths may lead to an overestimation of allowable stress and consequently an inaccurate estimation of the tool's lifespan. The N2 component on this figure primarily influences the longevity of super hard tools. It
limits the processing temperature to optimal to prevent structural alterations, which can lead to thermal fatigue and cracks on the working surfaces. The ideal material for tool blanks should possess low parameters. Notably, grain boundaries are more susceptible to damage than the grain body. Tungsten cobalt hard alloys are the preferred materials for tooling due to their optimal properties. In cases where wear-resistant coatings are applied to the tooling calibration surfaces, the problem arises of preserving its functionality during operations. Ensuring the fiber optic cable's quality characteristics significantly depends on the coating conditions, which is prone to cracking during finishing operations under the influence of thermomechanical processes due to its partial detachments from the primary materials of the calibration tool that can be found in this scheme and figure 3. By utilizing the functional relationship between the crack resistance and finishing operation parameters, the developed model and creation can effectively safeguard against tooling surface damage. Referencing to this figure 3, we can identify the designations. First is represents the wear-resistant coating. Second, represents the primary material matrix. Q denotes heat flow, and minus L plus L signifies the partial separations of the coating from the matrix. Additionally, sigma T and denotes tensile stresses in the matrix. Sigma C indicates compressive stresses in the coating. And conclusions. The complexities of thermomechanical process in material processing are carefully analyzed, considering their incoherent variations. Precise stress intensity factor calculations and primary control parameters are made to maintain the highest possible quality. It's achieved by establishing limit values for heat flow during machining, using criteria rations obtained from advanced modeling of thermomechanical processes. Processing parameters are selected to achieve the desired quality indicators for working surfaces and prevent undesirable defects such as burns and cracks. Through the use of electron microscopy on product surfaces prior to finishing, hereditary defects were identified in the study. The most notable defect was then chosen to establish criteria relations, tooling and processing modes. Furthermore, temperature and more fuel characteristics were closely linked to control and technological parameters, ultimately guarantee the necessary product quality. Thank you for your attention. If you have any questions, I will be glad to answer them.
Thank you, Maxim. Mr. Yuri, please, your question.
Does this medical model consider the influence of lubricant and coolant between the instrument and the process?
This mathematical model is includes calculated the temperatures by the system of differential equations. It can calculate and control the parameters like temperature fields and temperature characteristics in full system on full material, includes besides some inclusions in these materials.
Anybody else, please?
The main problem of this mathematical model is how correct, really, calculate cooling process. That's right?
That's right.
Because the conditions change chaque moment. Avec precision, it's very difficult practically have this calculation. That's right.
Mm-hmm.
Yes.
Yes.
In this problem, I think you must have many experience than such problem. Have you example real situation avec characteristic avec materials please.
This is the most theoretical equation. This is most theoretical model that can help to control parameters between the all systems parameters and parameters like grinding forces, speed, etc. But for measuring the temperature, we can use some optical measurement tools that can help us to understand what temperature we have on the first layer of the material.
Anybody else, please?
Please tell to us what your approach to this tool is different from approach of Professor Olsen, by the way, who is very short.
We to do this work together, so we prepared all equations together and work together.
Anybody else? Thank you. Maxim, you have this presentation about mathematical model of thermodynamic process in life of surface, yes, in machine part, yeah. My questions is about presented by you Laplace and Fourier, and how can this mechanism help you to solve the thermal problem in your quotients? Yes, about formulas.
Transformations of Fourier and Laplace is a very powerful mathematical model that can help to simplify the equations of thermodynamics and help us to control help us analyze the system, the temperature of all system.
Of all system,
yes.
Not only on surface, but in deep of part.
Yes, using these transformations to our equations, we can get results which can give us a representation of temperature and temperature field inside the material, and besides all inhomogeneities in this system.
Thank you. Anybody else can? What would Mr. Vasil, would you like to do the question? No? Thank you very much. Thank you very much for your very successful presentation once more.
Thank you very much.
Thanks. The sad presentation. My colleague, Professor Yaroslav Kusei from the Polytechnic University. Your presentation, please.
Thank you. Good day, dear colleagues. My name is Yaroslav Kusei. I am Associate Professor at Polytechnic National University. I am very happy to take part in your conference, and I will present the results of investigation, optimization of cutting modes during sustainable machining of products according to economic criteria, obtained of the researchers from the Polytechnic National University and University of Brescia. Constants of sustainable manufacturing and development of current mechanical engineering are closely related to provide the necessary and important parameters in social, industrial, social, economic, environmental direction of investigation. From other parts, economic criteria ensure the effectiveness of process media, which that includes metal cutting machine, clamping device, metal cutting tools, and other during product manufacturing. So the main aim of investigation is the development of a technique for optimizing cutting modes during parts machining by means of economic criteria. The main research tasks are analysis of economic criteria for product manufacturing, justification for the choice of the target function for object and functional-oriented technologies, adaptation of Markov chains to solve technological tasks in mechanical engineering, and optimization synthesis of technological process for product manufacturing. There are two main principles of technological process planning. Object-oriented technologies are closely related with step-by-step design according to regulated requirements. As usual, they used the typical technological process. The parameter optimization is the minimum technological costs during parts machining without analysis of conditional product conditional. The main characteristic of functional-oriented technologies is to provide the important operational parameters and reliability indicators with provision of accuracy parameter and surface parameter of surface layer. Economic criteria determine the degree of perfection and effectiveness for functional-oriented and object-oriented technologies. In our investigation, we analyzed the ways to estimate the direct manufacturing or machining time as the main element of piece calculation time or piece time during products manufacture. Target function of the optimization task is the minimum direct manufacturing time for object-oriented technologies. There are some techniques of calculation, minimum direct manufacturing time, that are widely used in mechanical engineering. Minimum direct manufacturing time is directly proportional with minimum piece calculation of piece time, and minimum piece of piece time is directly proportional with minimum technological cost. But the minimum technological cost analyzed the production cost during development and production stage. But the life cycle of a part consists of two stages, and we need analyzed product cost during these two stages. And as usual, the product with minimum technological cost require more production cost during operational condition. From this position, the calculation of the maximum direct manufacturing time is the actual task for mechanical engineering. The target function of the optimization task is the maximum direct manufacturing time for functionally oriented technology. And we suggest condition. From left side is the condition from the object-oriented technologies. We receive the minimum direct manufacturing time, and from the right time, the condition for the functional-oriented technologies. We can calculation the maximum direct manufacturing time closely related with the reliability characteristic and operational condition of the part. We developed the technique to calculate the maximum direct manufacturing time, analyzing the relationship between the element of process media, technological cutting machine, clamping device, and metal cutting tools, by means of the reliability theory and the Markov chains techniques. Markov chain techniques are widely used in IT technologies, electromechanical engineers, to estimate the reliability parameters for the specific system, which consists of standard elements with well-known reliability parameters, in particular intensity of failure. This approach can't be realized for mechanical engineering because the typical elements of mechanical system, jars, shafts, and other work in different conditions in different machines. We analyzed the possibility states of the elements of process media, metal cutting machine, clamping device, metal cutting tools, and workpiece using the Markov chains technique. The probability of ensuring the regulated parameters describes the current states of workpiece during pass machining. The probability of failures to ensure the regulated parameters of machines when limit states is reached describes the current states for metal cutting machine, clamping device, and metal cutting tool or tools. We created the technique to develop the technological graph and the system of Chapman-Kolmogorov differential equations for mechanical engineering parts during its manufacture. We realize this approach for machining of reduction jar housing, and in this investigation we present the results for operation 005 horizontal mill. We created the technological graph of reliability for this operation and developed the system of Chapman-Kolmogorov differential equation. You can see the solution of a system of the Chapman-Kolmogorov differential equations. We obtain the extending form of the exponential function for the probability of ensuring the regulated quality parameters of the part, and increasing form of the exponential function for the probability of ensuring quality parameters, probability of failures to ensure of quality parameters when the limit state is reached for metal cutting machine, clamping device, and metal cutting tools. Condition and solution to the optimization task, you can see on this slide the solution, and we realize this approach for the operation 005 for the reduction housing machine. The probability of providing of the regulated quality parameters is associated with the gamma percentile operation time to failure as the main parameter of the dependability. We solve optimization task for all variant of gamma percentile operation time, but we present the result for maximum operational manufacturing time and cutting modes for operation 005 for T equal 0.99. Conclusion. For the first time, the technique of optimization of cutting mode during path machining, according to the economic criteria and using Markov chains, is suggested. The target function serves the maximum machining time, maximum manufacturing time, at a specified technological operation or certain technological test during path manufacture. And further research will be very interesting to connect the results obtained at the development and production stage with the operational stage, because we need to analyze the process during all stages in life cycle of a part or product. Acknowledgement. This research has been conducted as a part of project between the Lviv Polytechnical National University and Kaunas University of Technology. And now we work very intensive in this direction with the University of Genoa, with Professor Aldo Atanasio and Professor Paula Walker. Thank you for your attention.
Thank you for your presentation. If is anybody who would like to take the question to our presenter? Please, Yuri.
Regarding the slide with Markov chains.
Okay, just a moment.
I thought. No, I'll give me a second.
Okay.
Here, the lambda parameter, what does it represent?
Okay, thank you for the question. We present the relationships between metal cutting machine, clamping device, metal cutting tool, and workpiece. And we received 4 states of the during part machine. State number one is probability of ensuring the regulated parameter of a workpiece. State number 2 is probability of failures to ensure the regulated parameters when the limit state is reached for metal cutting machine. State number 3 is the probability of failures to ensure the regulated parameters of product when the limit state is reached for clamping device. And position number 4, state number 4, is the probability of failures to ensure the regulated parameters when limit state is reached for metal cutting tools number 1, and position K plus 3 is the probability of failures to ensure the regulated parameters of product when the limit state is reached for K plus 3 metal cutting tool.
Thank you.
And so the same question. So this parameter has physical meaning or only as a coefficient?
What parameter?
Lambda.
Lambda. Okay, thank you very much. Lambda is coefficient in the system of Chapman-Kolmogorov differential equation, and lambda is the intensity of failures for metal cutting machine, clamping device, metal cutting tool on metal cutting tools, and in general, we analyze this process with meaning or analyzing of lambda is inversely proportional to the resource of machine or resource of metal cutting tool, clamping device, or metal cutting machine as one of the main parameters of dependability.
Thank you. Please, Mr.
It's very interesting report, but my question is, there are 2 main economical criteria.
Yeah.
The first, manufacturing time, and the second, manufacturing cost. Manufacturing time criteria, criterion, and manufacturing cost criterion. What is better, manufacturing time or manufacturing cost, and why? This is a complex question.
Okay, I said that we analyzed the ways to estimate the direct manufacturing time, but direct manufacturing time is directly proportional with piece time, and piece time is direct proportional with the minimum cost. And this position is your question. Thank you for your question. it's very, very interesting question. But if we need to save money, we will realize the variant with minimum technological cost. But if we analyze life cycle in general, two-stage development and manufacturing stage and operation stage, we need to analyze the process with the position of reliability. And economic criterion is the medium. I think, in my opinion, economic criteria isn't the main important, but one of the important, and we need in future we need to find the medium variant between the cost and reliability indicators.
Thank you. Thank you.
Thank you for your questions. Thank you
Anybody else?
for your
Question?
attention.
Thank you.
very much.
Thank you for your very interesting explanation for our this fourth presentation. Marina Halafeeva, yes?
Yes.
Please, lady, listen you with attention.
Dear poets, your attention is present the work called factor dimension using the acoustic infrared thermal method of inspection of non-metallic heterogeneous materials. Nowadays, the technical and economic prerequisites for the widespread using of non-metallic heterogeneous materials in the engineering industry. The multi-level nature of such materials provides ample opportunities for the synthesis of their physical and mechanical properties, which are manifested accordingly, can be evaluated through interaction with other objects. At the same time, the main attention should be paid to the defects that occur during the production of the products or as the result of operation. The effectiveness of the using of heterogeneous materials and constructions from them requires the measurement of reliable values of parameters of the internal process occurring in them at various stages of operation. On this slide, you can see the aim and research tasks. The proposed work is the development of implementation of methods for measuring the parameters of internal processes that occur in heterogeneous objects. You can see on this slide the research tasks too. The most interesting at the moment are non-destructive methods that make it possible to detect microscopic technological damages. It is promising to use the acoustic infrared thermographic method of controlling the specified class of materials. The implementation of active thermal control requires heating from the external energy source. There are various ways to implement such an impact. Optical, microwave, convective. The using of vibration perturbation of thermal energy is promising. This figure shows the schematic diagram of control of cracks in non-metallic heterogeneous objects by acoustic infrared thermographic method. The phenomenon of occurrence of temperature fields in heterogeneous materials with structural defects under the influence of vibration is primarily due to the dissipation of the energy of mechanical vibration on the defects, especially on the cracks. This method of excitation of thermal energy compares favorably with the fact that it does not lead to heating in the defect zone 3, and therefore increase the signal to noise rate. In thermal control methods, the thermal energy distributed in the research object is used as informative parameter. The temperature field is a carry-out information regarding theaters of hair transfer, which in turn depends on the presence of internal or external theaters. Infrared devices are used to obtain such information, most often in form of the thermograms. Anomalies of thermal energy distribution on the thermogram are explained by the presence of defects in structure of non-metallic heterogeneous materials. The highest reliability of non-destructive testing is achieved with the maximum signal-to-noise ratio, which can be obtained at the optimal time by recording several consecutive thermograms and choosing the best one from the point of view of noise. Such a thermogram has the status of an image to which all types of processing of data are applied. These concerns primary processing, segmentation, selection, and description of contours of thermal anomalies, and image analysis. On the slide 5, you can see the appearance of the experimental stamp and the carbon plate fixed on it, which was studied. The difficulty of evaluation and analysis of the thermal field of the investigated surface of products made of non-metallic heterogeneous materials is that the result depends on the scale of measurement on the scanning step. Therefore, the authors suggest using so-called fractal approach, which is invariant to the measurement scale. There are various methods to determining the fractal dimension. In the general case, they are reduced to the determination of the established characteristic parameter based on the change of which, at different scale levels, judgments are made regarding the fractal dimension. Moreover, in order of effectively use such an approach, it is necessary to take into account the particulars of specific research object. To determine the fractal dimension of temperature field anomalies on the surface of non-metallic heterogeneous materials during their flow detection, an effective and popular method of dimension calculation, box counting, was used. The method is widely used to calculate the dimension of sets describing various objects because it is simple and intuitive. You can see on this slide the calculation procedure. Research was conducted on the features of the structure of carbon plastic plate with defects made in advance. Delamination, you can see, I'm sorry.
Slide 10, 9.
8. Yes, thank you. Delamination, you can see, and the fact which obtained as the result of shock loading. As the investigated plate was subject to short-term action of energy of mechanical vibration. As expected, substantial absorption of sound waves was observed in defective zone, which manifested itself as anomalies of surface temperature field above them. Responding thermograms were recorded with the help of infrared devices, thermal imaging. The slide shows the appearance of investigated carbon plate and the resulting thermogram. Thermogram temperature anomalies are clearly visible on the thermogram. Layering is displayed under left corner. You can see this corner. And in the center of the plate, the right effect caused by impact load, around which an increased temperature is observed. This is explained by the presence of microcracks. Considering the received thermogram as a fractal object, general ideas about them were used for its analysis. The slide shows the contrast of temperature field anomaly of the surface of investigated carbon plastic plate, which reflect the presence of the defect, as well as the dependence to determine the fractal dimensions. When calculating the fractal dimensions of temperature field anomalies, the question of angle of their observation arises. The fact is that the surface itself, according to the thermogram, can be turned at some angle. At the same time, the fractal dimension cannot change from such a change of image, and the result of its calculation fully has the right to do so. This slide shows the same contours of the thermogram anomaly rotate by 90 degrees, 180 degrees, and 270 degrees relative to its axis, and shows the calculated values of the fractal dimension. It can be seen that the result of using the box counting method is sensitive to an aquafine transformation. This observed in most cases. Expectation are only objects whose fractal dimension perfectly match the theoretical values. For instance, an influence straight line fractal dimension equals 1, or plane fractal dimension equals 2. It is also necessary to know the accuracy of the results when they are rounded. Already, the third digit after the comma gives the difference in the calculated values. Thus, we have not one specific value to the fractal dimension, but their set. The range of these values for the object under study is small, and in principle, it is possible to enter the statistic value of the fractal dimension of temperature field anomaly on the surface of non-metallic heterogeneous materials, which is calculated using known methods of mathematical statistics. To do this, it is proposed to estimate the fractal dimension of a series of images of the studied contour, rotating it relative to its axis by a certain angle, going through a full cycle from rotation from the 0 degree to 360 degrees. After that, it is possible to obtain the value of the mathematical expectation and estimate the measurement uncertainty for the value of the fractal dimension, which will fully characterize the measuring results. On this slide, you can see the conclusion of the work. Thank you for your attention, and I'm ready for your questions.
Thank you. And other questions, please. Dear participants, please, who is for the first? Yuri.
In your experiment, you mentioned that you used the carbon fiber plate.
Yes.
Does this method is it applicable for complex shaped surfaces, not flat?
Okay, I understand your question. Thank you. The meaning is that we can control not very deep layers. For example, 6 millimeters. The form of the object is not. We have no difference on the work in this level.
Thank you.
Professor Tikhon.
One of the main characteristics of these materials is the coefficient of damping vibration. Will you make research these parameters?
Okay, thank you. The damping of vibration is consists from the frequency of the vibration. And we will have the difference in different frequency of vibration when we talk about dissipation characteristic on such materials. The experiments, such experiments we were made, but it is not the theme of this work. And it is very interesting question.
In future.
Yes.
Thank you very much.
Thank you.
Anybody else? Please.
I have a question. You have shown your stand.
Okay.
This electro engine. What is the aim of this stand?
To make the mechanical oscillation in different frequency. We have the plate, which were fixed on this stand, only to make the mechanical oscillation.
Thank you.
Anybody else? What would you like? Dear participants, I have one question to you.
Thank you.
Your presentation deals with only with non-metallic material. Have you any plan to go to do your research with metallic materials?
Thank you for your question. The process of occurrence, the temperature field on the defects by the influence of the mechanical ventilation passes in metallic materials too. But these processes are very fast in such materials. And our equipment could not allow for us to catch this process in that moment, in the optimal moment. That's why we propose to use this method only for non-metallic materials.
Thank you very much for your very nice and very interesting presentation.
Thank you.
Marina, thank you very much. And the next presentation, Yaroslav Pusey. Again, yes. It will be the finished presentation in our section, this section number 2.
Okay, good day, dear colleagues. I present the result of investigation, modeling of operational centrifuges concerning or functional interfaces of machine parts. Obtained the researchers from Lviv Polytechnic National University, Kaunas University of Technology, and Kielce University of Technology. Diversity and differences in operational condition, quality parameters require to use rational materials, development optimal structure of technological process, and choice effective strengthening meaning operation. In this part there are 3 kind of output parameters, and the most important part in the formation of the regulated parameters of the products have finishing and finishing strengthening of operation. So the main aim of investigation is the analysis of operation modes, technological devices for product strengthening using mathematical modeling. The main research tasks are developing the principal diagram for device modeling, developing the mathematical models for device modes of operation, determination of condition, provision of operation modes, electromagnetic vibration strengthening device, and analysis of non-working and working modes of operation for the electromagnetic vibration strengthening device. The regulated parameters of the products are provided different kinds of methods. Methods of surface plastic deformation are very effective to improve the operational characteristic and reliability indicators for the products which worked intensively working operational condition. Some of them based on the vibration technology which used to provide the quality parameters. Lviv Polytechnic National University is one of the famous schools to develop vibratory technologies to solve technological tasks. Methods vibrational strengthening, vibration centrifugal strengthening was developed at Lviv Polytechnic National University under the guidance of Professor Aftanasi. The devices with unbalanced and electromagnetic drives are used to provide the reliability indicators and operational characteristics. The principal scheme of the device with electromagnetic drive and real device you can see this slide. The electromagnetic device consists of flange 1 with rollers, the elements of electromagnetic drive, armature and stator with 3 electromagnetic coils, and these apparatus with deformable bodies connected to each other by means of torsion. We develop the principal diagram with some inception and describe it the system of differential equation. Equation 1 and 2 describe the oscillation into 2 different directions, and equation 3 describes the axial move of electromagnetic device. You can see the conditions, provision of operating modes. We differentiate the non-vacuum and vacuum modes based on the ratio between the amplitude of oscillation and operational gaps. Operational gaps is the gap between the deformable angle and the vacuum surface of products and between the elements of electromagnetic drive. Results. Non-vacuum modes was chosen for verification as the simplest to the mathematical calculation, and non-vacuum modes of operation characterized that there isn't contacted force between the deformable angle and the internal surfaces of product. You can see the results modeling of non-vacuum modes of electromagnetic vibration sensing device, which used in MassCAD. And you can see that after transient process, all elements of electromagnetic drive do harmonic oscillation with some amplitude. And you can see the phase portrait without force correction. Very interesting, the modeling of vacuum modes of electromagnetic vibration device, which characterizes the contacted force between the separators with the deformable angles and surface of product. And it's very interesting that the influence of contacted, you can see the oscillation of the separators and elements of electromagnetic drives and flange. And this influence we need to determine. We need to determine and agree with our design. The main conclusion: the mathematical model of electromagnetic vibration sensing device developed based on theoretical research using surface plastic deformation was suggested. And further research will involve modeling this operational electromagnetic vibration interference device using amplitude and force criteria for 1 cycle and 2 cycle vibration devices. Acknowledgement. This research has been conducted as part of project between Lviv Polytechnic National University and Kaunas University of Technology. Thank you for your attention.
Thank you, Yaroslav. If you who would like to take the new questions to present our Yuria? No? Mr. Larsen? Can you anything?
Vibrational strengthening process.
Yes.
Vibration
Yes.
strengthening process.
Yes.
What is the new direction in this process? What is this is well-known process. Well-known.
Okay, but next. Okay, vibration strengthening process. After the electromagnetic drive created between the elements of electromagnetic drive, amateur and stator, and this movement receives the dissipated, and they start vibration strengthening movement with contacted with the internal surfaces of cylindrical part. But its technology was developed earlier at Polytechnical, but the new approach is modeling this this process in real machines with contacted determination, and using the MATLAB instrumentary and devices to analyze and agreed it these results with realistic process.
Additional. What about time consumed, or what is productivity?
Okay. Okay. Thank you very much. Next, equation number 3. We can determine the productivity, change the axial movement of elements in axial of this device, and as usual, we need only one-time treatment to use the reliability and operational parameters for products.
Okay, thank you.
Thank you. And anybody else? Please, Professor, also прошу.
No problem. Maybe.
Because it's mathematics, I only understood, yes.
У вас система 3 рівнянь. Так? Перше, друге, третє.
Перші дві системи – це диференційних рівнянь, а третя воно символізує просто переміщення пристрою вздовж осі. Тобто, якщо повернутися...
Я хочу вас питати, а де початкові умови? Система тут сама має безліч розв'язків. Обов'язково необхідно поставити ще початкові умови.
Окей, я згоден з вами, тобто початкові умови. Ну, в даному випадку абсолютно згоден. Thank you. Agree. Thank you for your interesting question. And, okay. Thank you.
Anybody else? Would you like to take the question to our presenter? Thank you very much. Very nice finishing of this section. So our section is already finished, and asked to yes. We ask you to everything. Ask you to breakfast, brunch, lunch. No, coffee brunch. Yes.
Вашу роботу я читав. Я знаю вас.
Let's start session number. Difficult to machine steel. Professor Oleg Odiskov from Ivano-Frankivsk.
Colleagues, this very specific information, because as you listen, we are from University of Oil and Gas. So NC13 is a number of one of the connection of pipe of drill string. A little explain. Sorry, one moment. Okay. Introduction and major challenges. Drill string is manufactured part of every oil and gas well. So, and drill string may be from 3 to 5 kilometers long, but every pipe in this drill string is only 10 meters long. So you understood that it must be from 500 to 700 connector between pipe. So this term is about connector and problem when this connector manufactured from hard to machine material. For example, so this hard to machine material is steel, stainless steel, or hard alloy chrome nickel steel. And a few explanation about this connection. This connection between pipes in drill string consists from main two parts. Female part named as pin, and male part named as box, and name parts named as pin. So connecting realize by screwing in the pin into their box. Box is blue and the pin is yellow. Is it understand for everything? Yes. So screwing, it's may be realized because we have very big of in the pitch and taper thread. So this thread of box and this thread of pin together, it will be a thread connection named as a tool joint, and is special connection between very big pitch and a very big radius or diameter. But in that time, in this period, in this research, our study deal with only with a little diameter of this connection. This little diameter because it's very nice to understand how this very little diameter, only from 25 to 30 millimeter diameter, for drill string is minor, will be developed the process of turning, because every full time the turning of this kind of taper thread is manufactured by turning or less machine tool. Less machine tool. So machine tool is translated as turning machine tool. It's the second translate. So on this slide we can see two different kinds of instrument for tuning. This instrument, we understood that tuning tip. But the problem is that all world manufacturer proposed this instrument only with zero rake angle. They not proposed. Oh, I'm sorry. They don't propose positive rake angle instrument and negative rake angle instrument. Only zero. What does it mean for us as manufacturer? The drill string tool joint from difficult hard to machine. It's a problem because you know from literature, scientific and study literature, that not only the material of instrument is very important to deal with stainless steel or high alloy steel, but geometry is one of the main parameters of cutting process, not only in the tuning process, but in milling, etc. Here we deal with not only with tuning process because it's widely used, this instrument, in tuning process because it's very big thread. But as I explained already, this big radius, this big thread in this variant of our explanation is only from 25 to 35 millimeter long. Experimental results show that less cutting force, longer tool life, and better chip curling effect, and by the way, surface quality, was acquired for the insert with rake angle only 12 degrees. But another work substantially the choose of the negative rake angle, negative, of the carbide insert, -7 degrees, which provide increased stability when tapping in a steel workpiece in Ukraine and 35 H3NN with a hardness of 55 HRS. So our researchers in all the world produced only instrument with zero rake angle, but researcher help us to solve this problem and seduce its research about 12 degrees plus of rake angle and from 7 to 8 minus, from -7 to -8 degree. So where is the problem? Why the researcher cannot to supply the instrument with non-zero rake angle? Maybe because there isn't special formula, special authors or another author's algorithm to solve the problem of accuracy. But few words about in-feed process. You know that in-feed types in tuning process consist from 3 different approach to the in-feed process. One of them simple, radial in-feed, another flank in-feed, and once more incremental in-feed. Every of these type of in-feed must to ensure the accuracy of a thread, but one of the main problem of accuracy of thread is, as we know, the profile. So the standard of American Petroleum Institute, standard number 7, show that the accuracy of full half profile angle accuracy is 30 plus minus 0.75 degree. So our aim and our research at this picture from left, we saw the instrument passes, 12 passes, forming feet, and thread detail work. But here is the same, but looking at the microscope. Do you understand? Yes? Little and the same. The blue dashed line, this number 2, it's a line that is when the instrument does not research the limit, because limit is blue. What is it? This is a counter of thread. But red line is after counter, is already up at the limit of thread, according to the American Petroleum Institute standards number 7. So our research task was based on the algorithm according to our theoretical formulas. There is necessary to determine the value B, which functionally depends on the parameter of NC13. It's our taper thread tool joint, and front angle, but not but front angle is named in our department as a back rake angle, -8, as was explained before. And the second research task, on the basis of the obtained value of B, to predict a number of in-feed passes from maybe from 1 to 12, but predict it's only 1 or 2 of them, of in-feed passes that should be made with a tool with a 0 value of the rake angle to ensure the accuracy. Because maybe as the last in-feed pass, we received an upper deviation, because our limit is only plus minus 0.75 degree. So if we can, to ensure this accuracy, we can do it with instrument on all passes, as instrument with non-zero gamma, named as back rake angle. But if we cannot it, so we must to understand what does it mean B, how is this B is determined, and so if we understood that B is upper than we can do, in that we must to transport that last or maybe 2 last in feet must be manufactured by instrument with 0 back rake angle. Our formulas, it's interesting for everything because due to their standard in Ukraine, in American, in Soviet, in before period, is the same. So we have pin and box and connecting into the tool joint, and red line is a standard. And this standard red line, especially side of this thread, this straight side, can be explained only this one formula. This equation understood that as algebraic linear equation only. Alpha is a half of full profile angle, only half. Alpha deviation 2, and x is one of the coordinates, as you see. But we now already a few years ago, and dissertation here was in it, this formula, we obtained it to explain the formula, the blue line, and this line is explain and show us how really will be profile in our thread when the instrument will be with non-zero back rake angle. And named of this back rake angle is gamma. So here parameter gamma, and R here is radius only. So two parameters, but one of them is parameter of instrument. Here it is presentation of researchers before how many passes we must to do when we deal with this kind of thread. 12 passes of radial in feed, and two last passes is only on deep 35 and once more 35 micrometer. That's all you see radial in feet, and 12 passes from 0 to 12. This table is the same as here. Deal with the problem of tuning of our tuning thread. Here, the main part of our result and computer program calculation. Because we received the formula before, you saw it before, and our task was to model the problem of the tool joint or so mean connecting. It is for part of box and here pin. So the difference between point number C on standard line and point number C named as C1 non-standard profile is here show this different A, as we can calculate it by using the formula before, because we saw before that Z coordinate Z is function from X and gamma and R. So here is a difference between Z2 standard and Z1 non-standard, and it is A. Okay, so we received B. It's different between two profile non-standard and standard. We received this result. After that, we received this conclusion. It's our end of our research. In this conclusions two type, we propose that if we use the instrument with -7 or -8 back rake angle, our deviation of our alpha is only 0.27 degree. So, and it is 40% of the size tolerance. Size tolerance is, as you know, 0.75 degree. And in the second, if we want to unique this, we must, on the last passes, to use the instrument without back rake angle. I'm sorry, accuracy with back rake angle equal 0. Thank you very much.
Thank you, Lev.
Acknowledgement.
Does anybody any question? You can say about
precisions, yes.
But another factor maybe needs to consider. What about dependence, the angle, the performance of the
Yes, thank you. One of our tasks is performance, tangential deviation, for example. Do you understand? Instrument and axis of detail. and performance is tangential deviation, yes. And the other, the angle of lambda. Instrument must be when we have deal with thread with very big pitch. So we must to angle the instrument in the angle as a lead angle of screw. You understand? Lead angle, PDOM. So the instrument must be installed using this lead angle. So three, not only gamma, three parameter: gamma, lambda, and deviation. Thank you.
Other questions to Oleg on this call?
You are producing special threads. The main your operation is cutting.
Yeah.
Yes. But can you say about other operations? All list of the operations to produce your threads, not only cutting.
Yes, plastic deformation, for example.
Maybe
Yes.
grinding.
Yes, grinding. Yes. Thank you for your and you. Thank you for your questions. It's a very professional question, and I mean that I must to answer in that way, because all world do it type of parts only by using by a lathe, and so it's turning operation. So our main target is turning operation, but in the nearest future, we are going to deal with the wiring process. In Ukrainian, it's the wiring process called as вихрове точіння. So вихрове точіння is not multiple, it's not single, but multiple process as a milling. Thank you.
Other questions? Thank you. And I have one question. Describe your future direction.
Okay. Yes, it's the same. It's this question is deal with your question. Yes, because wiring process is very interesting, but not only for this taper thread, but with thread of not only thread but screwing. Screwing and the lead screw, by the way, lead screw, it's in Ukrainian translated as ходовий гвинт. So our interesting for the next InterPartner will be screwing and wiring process of screw lead. Thank you.
Thank you. Any questions to Lefonisko? Thank you, Professor Nisko, for your interesting presentation.
Thank you very much, and especially професору Конконогому, Усову, професору Віталію за те, що і професору Ларшину за те, що були присутні і дуже добре зустрічали мою дисертацію в свій час в стінах цього університету. Ось тому вам дуже вдячний і дякую, що я є тут завдяки вам.
Thank you.
Sorry.
Thank you for interesting presentation. And next presentation, features of magnesium alloy protection technologies in die casting. Kirill Kreiser, I invite you. Presentation.
Thank you.
Sorry.
Okay. Hello, my name is Kirill Kreiser, and today I want to tell you about my project is features of magnesium alloys protection in technologies in die casting. Introduction and major challenges. Let's start with the basic of this technology. Flux shielding of magnesium alloys is currently the most common in many industries, but it has a very large problems. The main one is that the interaction of the atmosphere and with oxygen and magnesium can lead not only to deterioration of the quality of the casting, and we have problem with this metal, but also to the emergency situation. The most advanced method of protection of magnesium alloys is fluxes defense with flux V2. The technology was improved, and we have a new technology with gases. We create pulsed gases supply and using him for magnesium alloys, for defense magnesium alloys with oxygen. I am in a research task of this work. The results of casting with the new technology were compared with casting with flux shielding technology. Next, microstructure studies with one technology and the next technology. And micro hardness measurements of the samples were also carried out. Research methodology, what I use in this project. To study and develop research task, we use a few factors on the protection of magnesium alloys during their melting and preservation when we use fluxes and when we use protective gases. I will tell you about the furnace installation for researching a new technology. We have injection molding furnace and die casting machine. This is supply circuit of pulse fluxes protection. We use one gases is SO2, and for the second line, we use gases SF6, and we use oxygen. They all go to the mixer trap, and in the end, they go to the furnace with liquid magnesium and protected him from fire. The mixer was supplied in a dynamic mode with a proportional valve of Samsung and Siemens with control over a given content impulsivity and taking into calculation with our new mathematical model of the content of these activity gases. The system provides an independent fire execution circuit for magnesium fire using new gases SF6. This is installation view in real life on the machine. This is die casting machine and our system with a two furnace with magnesium alloys. This uses a hot chamber injection molding machine, and it is used to increase efficiency and ensure fire safety model. And now we can talk about V2 flux protection. They all use in our Ukrainian projects. The system for compression from flux protection is a basic, in which special fluxes tablets V2 were used. The technology used is basic, but I don't briefly describe it. And results of these two technology. One technology is a flux protection V2, and the next our gas protection. Object of study: alloy samples obtained by the old and new improved technology, and the micro hardness of non-metallic non-metallic inclusions was determined using a PMT-free micro-hardness tester. And we have values, and they are shown in table 1. And we see we have so many values in our new technology with flux, with gases. Conduction research. When the samples were magnified on the microplan, a large number of dark brown inclusions. This is of non-metallic inclusions in metal when we used flux protection of V2. This is new research, and this is satellite inclusion in metal when we use V2. In these cases, this is our metal when we use new technology with gases, with SO2 and oxygen. And this is microstructure when we use flux V2. No non-metallic inclusion larger than 0.5 microns were found in new technology. And the microstructure of the alloys melted using the old technology consists of small, light angular grains of solid aluminum solutions in magnesium alloy and dark G-phase inclusion. The microstructure of the alloys melted using the new technology contained light rounded grains surrounded by less contrasting non-metallic rounded. This is of microstructure with new technology. And conclusion, the result of study of non-metallic inclusion by the new technology, we haven't problem with non-metallic inclusions. There are 0.5 only microns. In the samples of magnesium alloy AZ91D, and the samples of a similar alloy obtained by the traditional flux method V2 have been compared. A large number of small satellite inclusions were in metal. The study of the macro and microstructure of magnesium alloys produced with the new of the gas protection of magnesium alloys. And this new technology is now being actively used in Poland in magnesium casting plants. Thank you. This is all.
Dear all, we have some technical problem. Our participants from internet didn't hear the question for previous presentation. We have two variants of solving this problem. Please speak louder or go to the microphone to answer question of participant. And
No question.
does anybody have question? No question. Thank you.
Thank you.
Thank you, Kirill. Okay, I invite to another presentation, improved methods for diagnosing transformer with a defect in a high voltage bushing. Valentin Tikhenko.
Yes.
Please.
Improved methods for diagnosing an auto transformer with a defect in high voltage bushing. The reliability of modern systems for production, distribution, and consumption of electricity is largely dependent of high voltage oil field electrical equipment. In order to save time, let me not use abbreviation in this report. Well, failures of this equipment associated with electrical breakdown of capacitor electrical insulation of high voltage bushings are the most frequent and economically costly. The requirements for the maintenance of this equipment, taking into account its current state, determine the need to improve the system of technical control and diagnostics of such equipment. Determine the technical state of this equipment and with oil, paper, electric insulation is necessary for making this decision related to the operation, maintenance, and repair of this equipment, engineering and economic modeling in determining the most cost-effective alternative to restore or maintain this equipment. In this slide, you can see equipment big transformer and bushing phase A, B, C, for example. Bushing phase, for example, A. And there is bushing total slide. You can see phase N, B, C. The aim of the work is to increase the reliability and of the result of diagnosing of oil field power auto transformer with an internal defect in its oil field high voltage bushing with oil paper electric insulation, taking into account the results of their electrical tests and analysis of mineral transformer oil samples from them. Bushing, a device used for passing one or several live conductors through a barrier. For example, wall, transformer tank, reactor tank, etc. And insulating the conductors from the barrier. The bushing is furnished with an fastening pad flange or fixing, which is an integral part of the bushing attaching it to the barrier. Object of research. Methods for diagnosing auto transformer and its bushing based on the results of physical, chemical, thermophysical, electrophysical, gas chromatic studies of oil samples from its equipment. To identify the nature of the alleged defects of a thermal and or electrical nature, the use of the tabular method, the ETCPA method, and the dual triangle method is proposed. Investigated electrical characteristic. A, for autotransformer. Electrical resistance of electrical insulation, absorption coefficient, dielectric loss tangent of electrical winding, electric capacitance of electric winding. B, for bushing, dielectric loss tangent of the main electrical insulation, electric capacitance of the main electrical insulation, electrical resistance of a special output, the electric loss tangent of the electrical insulation of the measuring capacitor, electrical capacitance of the electrical insulation of the measuring capacitor, electrical resistance of the measuring output. The gas chromatograph was used to determine the following content of the mineral transformer oil: gases, total air content, total gas content, additive ionol, furan compounds, and the sum of their concentration. The studied characteristic of the oil samples from autotransformer and bushing is electrical breakdown voltage, flash pound of vapor, oil vapor in a closed crucible, acid number, water-soluble acids, dielectric loss tangent, density, water content, the content of additive ionol, content of gases, total gas content, total air content, the content of furan compound, and the sum of their concentration. The effect of high voltage pulsed electric current on the degradation of the furan compound type 2FLAL in oil in the presence of dissolved hydrogen was studied. In order to save time, let me not go to the details of the studies. To apply the Hess chromatographic methods for the purpose of diagnosing autotransformer and bushing, the following value were used: concentration of gases, total gas content, total air content. This is method of boundary concentration levels. Dual triangle method, triangle methods, ratio of gas concentration, tabular method. ETRA method. Water concentration, concentration of additive ionol, concentration of furan compound. The registered autotransformer. Oil weight 67,000 kilogram, very big, was put into operation in 1992. After 214 months of operation, autotransformer electrical tests were performed to determine the value of the main indicators in accordance with the requirements of regulatory documents. The result of electrical test shown that autotransform comply with the established standards. In this table, you can see a result of physico-chemical, thermo-physical, electrophysical studies of the property of oil sample from damaged bushing. The result of these studies of the property you can see in this slide. Let me not go into the detail of the study. Table 2, result of the gasochromatic analysis of oil sample from autotransformer is in follow from this table, depending on the duration of bush operation, the concentrations of gases dissolved in the oil practically do not change until are defected in this bushing based on electric tests. Before removing the damaged bushing from operation, the concentrations of dissolved gases in the oil, as well the CO2-CO ratio, increased, exceeding the limit value. At the same time, the concentration of dissolved gases in the oil constantly decreases and were within the limit value until defect were detected in this bushing based on electrical test. Due to the high content of dissolved hydrogen in oil, it is assumed that in the process of the occurrence of partial electrical discharge type defect in bushing, it's possible. The occurrence of chemical reaction of hydrogenation of CO and CO2 with the decrease in their concentration and the formation of CH4 and H2O in oil. The addition of hydrogen double and triple carbon bonds in unsaturated hydrocarbon molecules or the dissociation of oil hydrocarbons at C-C bonds. Table 3 present result of gas chromatographic determination of total air content and foreign compound contents in oil sampled from damaged bushing. The result of determining the content of this element and total air foreign content in oil sample show that bushing was leak-tight during operation. The concentration of 2-FeAl foreign compound and the sum of concentration exceed the norm. This point of the destruction of insulation in bushing. On figure 1, show the result of detecting the presence of an alleged defect by graphical methods. Here, you can see point N here above this temperature, point 2. By graphical method. Extra method, suspended defect type, heating more than this temperature, or heating and partial electrical discharge. B, dual triangle method. Value of the CH4, C2H2, C2H2 concentration. Suppose defect of the type heating over 700 degree Celsius. In this slide, you can see result of visual inspection and disassembly of the studied damaged bushing, this type, after opening autotransformer. A, this trace of electrical and thermal damage of the outer surface of bushing in contact with oil. B, electrical defects in insulation. C, electrical and thermal defects with trace of X-wax formation in insulation. D, partial electrical discharge and carbocol particle in insulation. Electrical and thermal defect in this insulation. When examining the outer surface and internal structural elements of the damaged bushing, after opening, defects were found: electrical and thermal in the outer surface in contact with the oil, electrical and thermal character with traces of the formation of X-wax and carbon particles in insulation. The formation on X-wax led to an increase in the electrical conductivity of the oil, decrease in the electrical strength of the oil, local heating and progressive destruction of oil. Figure 3 show the dependence of the content of the content fural compound, this type, in oil on the number of electrical breakdown N here in the volume of the oil saturated with hydrogen at an average breakdown voltage 65 kilovolt. In the work, a complex of experimental studies of the technical condition of autotransformer and its damaged bushing with oil paper electric insulation was carried out. The electrical characteristic of autotransformer and its bushing were obtained. The equipment method was used to determine the property of oil samples and the content of dissolved gases, total air content and furan compound in it, to identify the nature of the alleged defect of a thermal and or electrical nature, the use of the tabular method, the ETCPA method, and the Duval triangle method is proposed. When examining the damaged bushing, defects were found: electrical and thermal on the outer surface of the bushing in contact with the oil, electrical and thermal character with trace of the formation of X-wax and carbon particle in insulation. This makes it possible to assess the degree of influence of the damaged bushing on the presence of internal defect in the autotransformer. It's recommended to determine the content of furan compound in oil samples from bushing with insulation in causes where the result do not meet the standards for at least one controlled parameter when performing. Bushing electrical test, PCTE, studies of the property of oil samples, gas chromatic analysis of oil samples. Relationships between the concentration of dissolved components in oil in autotransformer and its damaged bushing, depending on the duration of their operation, have been studied. the effect of high voltage pulsed electric current on the degradation of foreign compound in oil in the presence of dissolved hydrogen, which is formed during the degradation of oil, is shown. Thank you for your attention.
Does anybody have any question? Professor Tihan, Professor Nisko, please.
Professor, can you explain once more why we saw two different natural gas in your explanation? CH4 and C2H6. So that I understand it, I mean that it is methane and
you can see about gases.
About gases, yes.
Yes.
Only two types. For example, C3H4, for example, propane.
Yes. Method gas chromatograph has chromatograph method may determine different gases, if their concentration, and we can see if this concentration is in norm or not. In this case, we can make requirement and real characteristic make compare was the reason. Yes, you are right. If is difference, we know change bushing.
You must change bushing.
And oil. If have not bushing, we have not electricity, we have not work, teach, and etc.
Thank you.
This is a main problem in the system, electric system of our country. Transformer may be in norm, but one phase A, B, or C may be damaged.
One of these phases,
Yes,
yes?
shock. Every transformer have phase A, B, C.
Yes.
Any questions?
What are the limits of damages? When we can say the object is destroyed?
It exists a requirement for this equipment. We must study this parameter, and after this operation, we must make a decision. What is the time of operation for this bushing in future? This is a diagnostic for determine time of operation of this equipment.
Thank you. Will you develop future investigation with Ukrainian colleagues or collaborate with some foreign colleagues from Poland, Romania, and others?
Sorry, in our condition, you can see we have not possibility in cooperation with our foreign colleague. But for our country, this problem is very, very important because one bushing is damaged, city, village, etc. Sans électricité. C'est tout.
Interesting presentation. Thank you.
Thank you very much.
And next presentation, evolution of dust concentration using computer measurement technologies, Professor Vladimir Lugnin. Please.
I greet you, my dear colleagues. Before starting the report, let me introduce myself. My name is Lugnin Vladimir. I am honorary professor of the Odessa Polytechnic National University. The presented article was co-authored with Gennady Aborsky, Lyudmila Perperi, Anna Goloborodko, and Vladimir Goloborodko. Subject of my report is evaluation of dust concentration using computer measurement technologies. I work at the Department of Digital Technologies in Engineering of Institute of Digital Technologies, Design and Transport of Odessa Polytechnic National University. Wonderful. Next, please. The solving the task of digital transformation is important not only in industry, but also in the field of higher education in the condition of pandemic and war in Ukraine. It is relevant to consider the issue of using modern information technologies to create virtual device and computing environment for modeling process and conducting virtual experiments. This work presents the creation of a program for analyzing measurement results in the Scilab software environment, which simulates the process of determining dust concentration using computer measurement technologies. Air pollution is a growing problem in many countries, and here it is dust being one of the main contributions for poor air quality. To ensure air quality control, it is important to monitoring of particulate matter concentration, which is important for supporting the overall quality of the application. And next, the accumulation of tool for the wide concentration of soil particles in the main tendency. The computer technology of the simulation of the development of an increasingly important role in this process. Next. The aim of this thematic study is to develop a program for automation process of measurement results and the visualization in the form of topographic graphs of room conditional levels. This will enable researchers and engineers to effectively conduct modeling and measurement of air quality control process by utilizing mathematical, numerical, and analytical methods with sequential graphical visualization in safe environment. To achieve this goal, the author of the study solves the following tasks. First of them, to describe the process using mathematical modeling. Next, made a software implementation of the process. And third, to test the virtual instrument and analyzing the obtained results. Next, please. The input parameter of modeling the process are files with the result of measuring the number of dust particles of different size in a cubic meter of air. The concentration of dust particles is measured using the device which called Watson HT 900 1600 air dustiness tester. Look at the picture at right, please. This tester has 3 channels for measuring the concentration of dust particles in the ranges from 0 to 0.3 micrometers, next more than 0.3 to 2.5 micrometers, and at last more than 2.5 to 10 micrometers. And it is also equipped with a micro USB data transfer port to computer. To implement the program for process the measurement results, a program was created for simulating the process of determining the concentration of dust in residential or industrial premises. And our sampling plan is drawn up for each room. Look at the picture at right, please. Next, please. Software implementation of the process. To implement the program for process the measurement results, a program was created for simulating the process of determining the concentration of dust in residential or industrial premises. Simulation of a virtual device for measuring the concentration of aerosol particles in an industrial premises was carried out in the Scilab software environment, and air sampling plan is shown up for each room. The air sampling plan should include first specifying of sampling point, next specifying the frequency of control for each point, specifying the number of samplings at each point, next indication of the time of the working day when sampling is carried out. Next, indication of the nature of the technological process at the time of sampling. And at last, designation of critical control points. Next, please. The number of sampling points should be at least 2. When the content of particles in room, which vertical unidirectional or non-unidirectional airflow is determined, the sampling point should be eventually described in a plane parallel to the plane of the flow or vertically, if it's necessary. In rooms with non-vertical unidirectional airflow, the plane of sampling points should be perpendicular to the airflow direction. Suppose some sampling points full of places occupied by equipment when the content of particles in the air is determined. In that case, they are moved to places most critical to the requirements for processing product or technological process from microparticles. Control of the content of particles in the air should be carried out in strict according with the simple plan. Then taking samples should be observed. Sampling isokineticity or equality of air velocities in sample and the flow under investigation. And next, sampling isoaxiality. The sample must be oriented so that the direction of movement of the air flow entering the sample coincides with the direction of movement of the unidirectional air flow from which the sample is taken. If the flow direction is not clear, the sample is oriented vertically upwards. Next, please. When determining the content of particles in the air, the minimum number of air sampling point, capital letter N, is determined by rounding up to a large number in accordance with formula which you can see in our slide. If for each room and the ice sampling point, the average arithmetic value of capital letter A and the calculated concentration of particles per 1 cubic meter is calculated in accordance with second formula. Look at the picture, please, at the screen. From the average R sub I, the average arithmetic value capital letter A of the calculated concentration of particles in 1 cubic meter of air of the entire room is calculated in accordance with the last formula. Next, please. The point estimates the mean square deviation capital letter S of the result of the measured concentration is calculated in accordance with the formula which you can see at the screen. The calculated concentration of capital letter C particles in 1 cubic meter of the air of the industrial premises, taking into account the confidence interval, which is calculated by the formula number second. The calculated values of calculated concentration of particles capital letter C is 1 cubic meter of the area of the industrial premises and A sub I of the average arithmetic value of the calculated concentration of the particles at each sampling point should not exceed the maximum permissible number of particles, which is provided for premises of a certain cleanliness class. Next, please. When the program starts, a window will appear with an offer to enter the value of the confidence probability. The window can be filled with the required probability value and then button OK should be pressed. Look at the picture. The value of the confidence probability is entered to obtain the result of the dust concentration measurement of each channel of the device. Next, please.
More louder, because I don't hear you.
Excuse me, I will try to do it. When the program is launched, a graphical window of Scilab appears on the computer screen with an invitation to enter the confidence probability for calculating the dust concentration result for the first channel of the device. Look at the picture. Next, please. After entering the numerical value of the confidence probability of the dust concentration calculation result, a topographic image of the distribution of dust concentration in the room, and the offer to enter the confidence probability of the calculation result of the measurement result of the second channel of the device will appear in the graphic window. Look at the screen. Next, please. After entering the numerical value of the confidence probability of the result of the calculating the dust concentration for the second channel, a topographic image of the distribution of the dust concentration in the room, and the author to enter the confidence probability of the calculation result of the measurement result of the third channel of the device will appear in the graphic window. Look at the screen. Next, please. After entering the number value of the confidence probability of the result of calculating the dust concentration for the third channel, a topographic image of the dust concentration distribution in the room will appear in the graphic window. This completes the calculation. Next, please. Advantages of using virtual tools. The task or design of function is necessary directly for the user rather than rigidly determined by the manufacturer. Ability to apply quick data retrieval and analysis of obtained measurement data with sequential application of a graphical interface for visualization. Ability to apply virtual device in conjunction with networking technologies. To use of the freely distributing Scala programming environment allows significant cost saving in the development of the error quality assessment system compared to LabVIEW and MATLAB, which have slightly larger toolsets. The potential for application in the education process, both for developing practical skills in students, for designing virtual devices, and for conducting experimental evaluation based on the data obtained from the already created devices. It also contributed to understanding the economical aspect related to the need for preserving the error quality of equipment. And next, please. Modeling the process of determining the concentration of dust using computer-aided measurement technologies is an available education tool for students majoring in information and measurement technologies, which provides students with hands-on experience with the equipment and method used in air quality monitoring and allows them to experiment with various variables in a safe and controlled environment. The proposed program for modeling the process of determining error destinies is used during laboratory work and practical classes, including distance learning. By using simulation, students can gain a deeper understanding of the importance of maintaining good air quality. In addition to the additional process, this technology is highly available, creating dust control report in industrial premises. By utilizing the Scala package in industry to solve indoor air quality control problems has limited possibilities of tracking change in dynamic according to the topographic graph. To solve this problem, it is possible to use another graphical programming environment as LabVIEW, which has a more available set of tools. However, it is necessary to have a valid license for LabVIEW, unfortunately. Next. Thank you for your attention.
Does anybody have any question? No. Thank you.
Thank you for your attention.
We finished our work, and the next section will start in 2 minutes. Because we don't have a break because now 1 minute to our session. Thank you.
We can start our next session. Session number 3 has the title Manufacturing Technology and Machining Processes. My name is Vitaly Ivanov. I will be the session chair during this period, and during this session we will talk about surface relief, workpieces oriented movements, regularities of oscillations, impact of the cutting fluid supply, jam machining, customized orthopedic implants, and wear of caliber rolls. During this session, we will hear 7 presentations, seven new studies, and I believe it will be interesting for all of you. Among our participants are scientists from Ukrainian, Polish, Turkish universities. I am happy to introduce all participants and I encourage all of you to ask questions to our participants. It will help significantly them to further research. So our schedule for our meeting is the following. Now we will start video presentations of all 7 participants, and after that I will invite you to discuss questions and make some comments regarding the presentations. So our presentations will be according to our agenda. The first presentation will be by Natalia Balicka from Zhytomyr Polytechnic State University. After that, we will hear the presentation from Irina Cherepanska and her research team. After that, research team from Zaporizhia Polytechnic National University. Next will be the presentation of our colleagues from Crimean Engineering and Pedagogical University. And in cooperation with Yildiz Technical Universities from Turkey. Also, next will be the presentation from our colleagues from Lviv Polytechnic National University in cooperation with Uczelnia Państwowa imienia Jana Rodka from Poland. Next will be the presentation from Kyiv Polytechnic Institute in cooperation with LLC Osteoanica from Ukraine. And the last presentation in this session will be delivered by participant from Technical University Metinvest Polytechnica. Now we are ready to start our video presentations, and after the 7th presentation, I will come back and we will discuss about it. Enjoy this time, and let's talk about it a little bit later. As you can see, the total length of 7 video presentations will be 1 hour 47 minutes.
On.
Good afternoon, dear participants and host of the conference. I would like to present my report on the multifractal analysis of periodic surface relief of parts after face milling. The relief, which is formed on the surface of parts applying various machining methods, is one of the factors that determine their functional properties at micro level. Therefore, the development of experimental research methods and mathematical description of surface relief within small spatial scales is considered to be an important theoretical and practical task. By this time, a whole range of quantitative characteristics has been developed and widely implemented in practice to describe microrelief of sample surface. Typically, different measuring devices can be used to measure these characteristics in a relatively easy way. The harmonic analysis approach, namely the Fourier series, should be also recognized as an application of spatial relief linear characteristics. It should be recognized that the application of harmonic function rows featured by a low convergence rate makes the task rather mathematically complex and cumbersome. The methods using power series theory and fractal system structure concepts have to be considered as unusual ones. Such methods are used to describe surface conditions in which the spatial features of surface relief are taken into account, and they rely on the principles of self-similarity and more general forms of symmetry. The approach based on introduction of fractional dimensions to describe microspace geometry could make it possible to provide further theoretical description of many phenomena which are difficult to interpret with classical physical concepts. This situation stimulates the use of fractal representations to describe the process occurring at machining. This slide presents the definitions of the Hausdorff dimension and Rényi numbers. The Hausdorff dimension is the main parameter in monofractal analysis. The Rényi numbers in our case, there are box counting, information and correlation dimensions are used as multifractal dimensions. This slide presents comparison between Euclidean and fractal geometry. There are 4 topological dimensions in traditional Euclidean geometry: 0 for points, 1 for straight lines, 2 for planes, and 3 for volumetric objects. An object that is fractal has an intermediate dimensionality, such as 1.6 for an irregular line or 2.4 for an image surface. One of the directions solving the problem of mathematical description of surface state is associated with application of the fractal analysis if A methods. It does not seem justified to ignore the influence of appearance of other forms of symmetry, namely the fractal ones, on formation of final mechanical and thermodynamic properties at the precision level of their studies. Presently, there are an insufficient number of works devoted to the development and application of the multifractal analysis to the description of part surfaces after machining. It is known about the works on influence of cutting conditions on roughness and the corresponding fractal characteristics of the surface. In such works, as the initial parameter for fractal parameterization was choosing the length of the surface profile line. It's not absolutely clear in which physical models of the cutting process this parameter can be utilized. In the mentioned studies, the fractal dimension was calculated on the basis of the analysis of two-dimensional profile images and did not take into account the entire spatial pattern of the relief. The importance of choosing a geometric parameter of a system for its fractal parameterization is pointed out by many authors. The fractal analysis method was used by us in previous works to solve the problem of describing periodic surface relief formed after face milling. The use of standard mathematical programs made it possible to perform calculations for fractal characteristics of steel and aluminum alloy surface. However, it's unlikely that the use of Hausdorff dimension alone will be sufficient to fully describe the complex shape of surface relief. In this respect, it might be preferable to use multifractal analysis to describe such a complex system where the system is characterized by ranges numbers. Thus, the purpose of the given paper is to quantitatively prove the presence of fractal symmetry and self-similarity phenomena for the surface areas and volumes of microforms which are naturally formed on specimen surface as a result of face milling by applying the MFA mathematical tool. The particular attention was paid to the selection of the physical parameter that completely characterizes surface condition of specimens and is subjected to fractal parameterization when applying the MFA. The surface area and volume of surface elements were selected among the possible geometric parameters of special shapes that are formed on part surface. These parameters basically determine the surface energy of the system and form the microsurface relief of the sample. The ranges numbers, as well as fractal ordering parameter, the degree of fractal symmetry disruption, were chosen as the most informative multifractal parameters capable of describing surface structure. The value of the range numbers ds0, ds1, which is equal to 2, corresponds to ideal flat surface within the fractal formalism. The volume next to the surface is filled with material and it corresponds to the value of the ranges number dv0, dv1 are equal to 3. The specimens for the study were obtained by milling. The cutting tool was a milling cutter with 4 positive pentagonal inserts made of carbide alloy with a titanium nitride coating. The specimens were the plates of steel and aluminum alloy. The spindle speed and the feed rate were chosen as constant parameters for the study. The depth of cut was a variable parameter. Digital camera was mounted directly on the microscope. The surface was photographed in reflected light. The uniformity of illumination was ensured by using a set of LEDs, which were evenly arranged on the ring holder around the specimen. The figure demonstrates surface photographs of specimens after face milling. They were processed by the MFA methods using the developed software. The MFA implementation was carried out in accordance with the standard procedure. The generation of measure of each cell of the space was performed by dividing the space covering the base measure set into cells. The basis size were calculated by triangulating the digital picture of the actual surface. The multifractal spectrum parameter search was conducted by using the method of coarse partitions. General statistical sum was compiled for a cell of the given size for both surface area and volumes. If there is fractal symmetry in the analyzed physical system, all the obtained calculation dependencies shall consist of a set of points grouped along straight lines. The calculation of linear parameters regression between the specified parameters of the system was performed by the method of least squares for each among the selected values of magnification number Q. The main results in the study are calculation of generalized statistical sums for the areas and volumes of spatial microforms, proving the existence of self-similarity and fractal symmetry of spatial microforms formed on the surface of structural steel and aluminum alloy after face milling. Discussion of correspondence of characteristic functions of performed multifractal analysis with their canonical forms. Discussion of quantitative relationships between the multifractal spectrum parameters of the surface areas and volumes of microforms formed by face milling and cutting conditions. The most important calculation outcomes, which should be regarded as the most significant quantitative proof of the existence of fractal symmetry between geometrical parameters of surface microforms, are demonstrated in the figure. The graphs show a typical form of statistical summation from changes of surface areas of microforms and their volumes on the given length of an edge of space unit cell in the method of coarse partitioning for the set of numbers Q. The experimental data are distinctly grouped along straight lines. The very presence of linear relationship among the analyzed in logarithmic coordinates is known to be the main proof of self-similarity existence in the system. Moreover, that is the multifractal spectrum that is typical for the surfaces under consideration and is a promising method for describing such systems. Therefore, it is the multifractal system parameters that are recommended to be applied when describing the surface condition of the specimens obtained under the specified conditions. The figure makes it possible to conclude that characteristic functions correspond to their canonical forms. This means that the sequence of the Rény's numbers is decreasing. The function sequence alpha hat is specific maximum and the distinctive for the MVA fracture is observed on the dependency tau q. This result is an equally essential proof of self-similarity and fractal symmetry properties within the system of relief-forming microforms. The data in the figure show that the given study found the relationships among the Reynolds number for surface area and microform volumes and depth of cut at constant feed rate and spindle speed. The straight lines in the graphs were drawn by averaging the experimental dependencies of considered multifractal parameters on the relevant cutting conditions using the method of least squares. There is a transition from the soft cutting conditions typical for the finishing to the hard ones observed at roughing as cutting depth increases. The surface becomes more non-planar and its Reynolds number for the surface area increases, deviating more and more from 2. Such a conclusion is also confirmed by the Reynolds numbers dependence for microform volume, which tends to decrease at cutting depth increasing. This course of dependence corresponds to an increase of overall non-planarity of the final surface when dV0 demonstrates an increasing deviation from 3, reflecting the appearance on unfilled volumes near the surface specimen. The fractal ordering parameter is an important parameter of fractal spectrum. In general, the width of the fractal spectrum increases with the transition to more energy-intensive machining modes, which are typical for roughing. The sensitivity of these surface parameters to an increase in cutting depth, even for materials with significantly different physical and mechanical characteristics, is approximately the same. The main conclusion of this study are: the MVA method was applied to image processing of the surface of specimens after phase milling. The existence of self-similarity phenomenon and fractal symmetry between microforms that form specimen surface relief was quantitatively proved. The multifractal spectra of the surface area and volumes of microforms formed on the specimen surface when cutting were calculated and analyzed. It was shown that fractal symmetry was present even in a system whose surface is periodic due to the impact of a tool age. The data on the dependence of multifractal spectra for the specimen surface on the milling condition were obtained. It was demonstrated that Reynolds numbers and ordering parameters are in close correlation with the depth of cut. Thank you for your attention.
Dear colleagues, thank you for the opportunity to present our article, Quaternion Model of Workpieces Orienting Movements in Mechanical Engineering and Instrument Making. Modern production rates of mechanical engineering and instrument making productions impose new higher requirements of the workpieces orientation systems, productivity, and provide for their simulation. The task of WOS simulation is one of the most challenging, which is solved during the Flexible Manufacturing Systems (FMS) design, in particular mechanical and instrument making engineering. For this reason, it requires the use of efficient, universal and efficient methods and mathematical operators. for the simulation of orientation movements, which are performed by workpieces during automatic orientation. The process of automatic orientation means workpieces transferring from the initial non-oriented position INP to the predetermined final oriented position VOP in absolute Cartesian coordinate system XYZ by performing a set of circular and linear motions that make up the composition of orienting movements. It is obvious that the complexity of the equations of the mathematical model, its accuracy and computational complexity affect the effectiveness of the modeling of the WOS as a whole. Traditionally, rotation matrices, Newton-Euler equation, Euler-Krylov angles, or Bryant angles are used to describe circular motions and movements of rigid body. However, all these models are rather complicated and cumbersome, require a lot of computing costs and intellectual efforts. Their significant complicates and slows down the modeling process. Models do not provide any possibilities of the mathematical description of the linear motions of the OM during their automatic orientation, and therefore the obtained mathematical model does not fully reflect the structure of orienting movements of the workpiece. That is why it is necessary to use new approaches and mathematical apparatuses of quaternions to build mathematical models of the orienting movements of the OM and the simulation of the WOS, which will help to solve the existing problem. An excellent alternative can be so-called quaternion model of workpieces orienting movements, which allows describing both circular and linear motions of workpieces. The idea of using quaternions to describe the actual circular motions of rigid bodies is not the new one. Quaternions are used for tasks of dynamics and spatial measurements of angles because they allow to simplify the equation of the model of circular motions, increase computational efficiency and accuracy. However, there is no information regarding the use of quaternions to describe workpiece linear motions of, and accordingly, the full composition of their orienting movements during automatic orientation. Quaternions Q are powerful and effective mathematical apparatus for modeling process of orientation of rigid bodies in 3D space. Graphically, the equation is represented as the sum straight line V in the space C. That is the vector V around which the object rotates. Quaternions consist of scalar and vector parts. The scalar S and vector V parts of the quaternion Q are formed by the ordered sequence of real numbers S, A, B, C associated with the four basic elements 1, Y, J, K. At the same time, the basic elements I, J, K of the quaternion Q make up a trio of orthogonal unit vectors that are pairwise collinear with the corresponding axis of the Cartesian coordinate system. Depending on the task condition, it is convenient to represent the quaternion Q in the form scalar number S and 3D vector V, hypercomplex number, 3D vector of Euclidean space at S equals 0, trigonometric sum of scalar number S and vector V. The absence of the singularity, the relative simplicity of mathematical operations, and the compactness of equations are positive feature of quaternions Q. That is why there is no doubt the useless of quaternion Q as a model of workpiece orienting movements in VMS of machine and instrument engineering. The use of quaternion Q to describe the movements of workpiece and determine their position in 3D space of the Cartesian coordinate system, which is used in mechanical and instrument making engineering, is based on the rules of multiplication of basic elements, as described on this slide, and the following properties of quaternions. Commutativeness, that is the possibility of permuting arguments, and associativity, that is the possibility of performing operations in arbitrary order when adding. Non-commutativeness, that is not the possibility of permuting arguments, and associativity, that is the possibility of performing operations in an arbitrary order during multiplication. And distributiveness. Operations with quaternions involve a combination of the rules of scalar and vector algebra. Thus, the length of the vector v of the quaternion Q in 3D space is determined by the formula described on this slide, where v vector of part of the Q quaternion. The vector v sets up the direction of the object's rotation axis and goes from the point O of the beginning of the Cartesian coordinate system to point M with coordinates A, B, C. It is obvious that quaternions allow to describe all types of orienting movements of workpiece, circular and linear motions. During automatic orientation of the workpiece in the 3D space C, it is necessary to perform the transformation of the finite set of circular and linear motions so that the workpiece occupies the final predetermined position in the space C with the vector of rotations and angular coordinates of the workpiece respectively. In other words, the workpiece during automatic orientation must perform a certain set of circular and linear motions relative to 1, 2, or 3 axes of the Cartesian coordinate system in 3D space C. In quaternion concepts, the above can be interpreted as a displacement of the local Cartesian coordinate system connected to the workpiece relative to the absolute Cartesian coordinate system of the 3D space, with the basis ijk by some angles relative to the axis, the direction of which is given by the unit vector v, as shown on the slide. The geometric properties of the orienting movements of workpiece relative to the axis OX, OY, OZ of the absolute Cartesian coordinate system XYZ of the 3D space C can be expressed in the quaternion form as shown on this slide, where alpha, beta, gamma, the angles of rotation of workpiece relative to the corresponding axis of the absolute Cartesian coordinate system of the 3D space C. Accordingly, the oriented position obtained by the workpiece as the result of circular motion in the 3D space of the absolute Cartesian coordinate system at some angle relative to the axis of the direction of which is given by the unit vector v can be determined as the product of the corresponding quaternions according to expression shown below. The oriented position obtained by the workpiece as the result of linear motion in 3D space of the absolute Cartesian coordinate system can be defined as the sum of the corresponding quaternions as shown below. Colleagues, on this slide is shown generalized quaternion model of the workpiece orienting movements. Results. The application of the quaternion model to determine the geometric parameters of the orienting movements of the workpiece involves the performance of only 11 mathematical operations in 3 stages. For the first stage, it is necessary to submit the magnitudes of circular motions in trigonometric form. At the second stage, it is necessary to calculate the product of quaternions according to the above rules. At the third stage, it is necessary to determine the arccos of the angle of rotation in degrees from the scalar part of resulting quaternion, and from its vector part to select the coordinates of the point M, to which the vector v, which sets the direction of the axis of rotation of workpiece. For example, calculations of the geometric parameters of the orienting movements of the arbitrary workpiece. With automatic orientation of the workpiece, it is necessary to transfer from the INP to the FOP relative to the absolute Cartesian coordinate system XYZ by performing circular motions relative to the axis to the corners alpha, beta, gamma respectively. The geometric parameters of this process are defined as the product of the corresponding quaternions, as shown below. The obtained calculation results can be interpreted as follows. During automatic orientation by the workpiece in 3D space of the absolute Cartesian coordinate system is rotated by the angle 55-24 relative to the axis of the direction of which is specified by the unit vector v, which goes from the origin of the coordinates of the point O to the point M, as shown on this slide. When quaternion model of workpiece orientation movements is used, it is necessary to perform 11 mathematical operations, in particular 4 multiplication operations, 3 divisions, 3 finding the root of the number, and 1 trigonometric operation for determining the arcos angle in degrees. For comparison, it should be noted that the usage of matrix models for guiding cosinus or Euler angles or for similar condition involves the performance of significantly larger mathematical operations. The above-mentioned points out to the significant effectiveness of the quaternion model, increasing productivity and reducing the complexity of the procedure for determining the geometric parameters of the workpiece orienting movements. In addition, taking into account that the production conditions automatic orientation is carried out as the rule for large batches of workpiece, saving computational resources and reducing the time for performing mathematical operations can be quite large. At the same time, significant increase in performance and speed of calculations and modeling in general is obvious. Therefore, the use of quaternion model will allow to reduce labor intensity of the performer task, reduce time, and increase productivity for the simulation as well as the process of automatic orientation of the workpiece. Conclusions. The conducted research and computer simulation confirm that the possibility to use the pioneered quaternion model for the industrial purposes in mechanical and instrument-making engineering, as well as WOS simulation. The obtained results are essential and show that the productivity of the performed task and their speed increases approximately 40%. At the same time, computational costs and intellectual efforts are significantly reduced in comparison with traditional methods of describing the movements of workpiece, which are based on rotation matrices. After all, quaternions provide the information necessary to orient the workpiece using only 4 numbers instead of 9, as in traditional rotation matrices. These stimulate to use the developed quaternion model at the pre-production stage in mechanical engineering and instrument making. Thank you for your attention, colleagues.
Good afternoon, dear conference participants. My name is Pavel Trishin. I work as a lecturer at the National University Zaporizhian Polytechnic. This report is devoted to the regularities of oscillation in turning and milling. During machining, under the action of the cutting force, the elastic system's tool parts goes out of equilibrium and oscillation of the system appear. To control and reduce vibration, enough research has been carried out, the main task of which was ensure surface quality and processing productivity. Many methods have been developed to suppress vibration. The following methods are most widely used. Using high-feed insert, using variable geometry tools, changing the cutting speed. Simulation of the general reaction of the assembly of the spindle and tool to the cutting process, using the stability lobe diagrams, It should be noted that the studies consider either the overall effects of vibration on the cutting process without division into types: forced, free, self-oscillation, or the influence of self-oscillation. The purpose of the study is determine of patterns of action of various types of vibration during turning and milling, to determine of priority types of vibration for various machining methods. Research tasks are: develop of research methodology, develop device for research, conduct experimental studies, analyze and results, and summarize. It's known the forced oscillation are formed during cutting. Forced oscillation are oscillations that occur under the action of external periodical forces. These oscillations are characterized by period and amplitude. Also, free oscillations are formed during cutting. Free oscillations are oscillations that occur in a system under the action of internal forces after the system has been taken out of equilibrium. Under the action of friction forces, free oscillations are damped. The amplitude of free oscillation depends on the initial conditions. Self-oscillation are most harmful during cutting. Self-oscillation and damped oscillation in dissipative dynamic system without external oscillatory influence. The self-oscillation amplitude does not depend on the initial conditions. In addition to the listed types of vibration, it is noted in the literature that accompanying free oscillation occur during cutting. Accompanying free oscillation of the technological system is oscillation when the tool cuts into the part. These oscillations have the characteristics of the free oscillation. To determine the regularity of action of vibration, a study was carried out during intermittent turning of cylindrical workpiece with a longitudinal groove. Turning provided a large cutting time. The turning frequency was provided by longitudinal groove. The research device was a cutter in the form of oscillator. The oscillation amplitude of the cutter was measured by displacement sensor. The design of the device used made it possible to adjust the dynamic characteristics of the cutter, registered its oscillation during cutting, and determine the cutting time. The samples were used from steel 45, and the cutter had VK8 hard alloy plate. Study of the regularities of the occurrence of vibration during milling were carried out on a special stand, which allows simulation the processing of parts. The device for measuring vibration was a oscillator, on which the sample was fixed. Up and parallel milling was carried out at axial depths of cut of 4 millimeters, a radial depth of 0.3 millimeters, a feed per tooth of 0.1 millimeters, and spindle speed of 120, 200, and 700 RPM. The design of the device used made it possible to control the dynamic characteristics of the sample, registered its vibration during the cutting process, and determine the cutting time. Samples were used from steel free and mill from high-speed steel with a diameter of 16 millimeters. The vibration recorded during the turning of the workpiece with the groove have characteristics features inherent in all types of vibration. At each revolution, the cutter hits the workpiece. As a result, forced oscillation occur. Forced oscillation occur under action of the cutting force. which presses the workpiece by the value of bx. They are superposed by damped accompanying free oscillation of the technological system with a period of TAO. A wavy wake appears on the cutting surface, which is the source of undamped steady-state self-oscillation with period TCO. Self-oscillation becomes steady after the transition period and before leaving contact with the workpiece. Then the workpiece moves in the absence of cutting, where a damped free oscillation of the cutter relative to the position of elastic equilibrium with a period TFO. Based on the results obtained, it can be started then regularity of action of vibration during cutting has the following sequence: forced oscillation superimposed on the accompanying free oscillation and self-oscillation. Free oscillation of the cutter relative to the position of elastic equilibrium after the end of cutting. Each type of oscillation has its own duration. Forced oscillation act during the entire cutting time, T-cut. The accompanying free oscillation act during the time TAO. After the attenuation and before the end of cutting, self-oscillation take place during the time TSO. The free oscillation time of the cutter is determined by the idle time TIR. From the end of cutting to the next cutting of the tool. Vibration during milling are characterized by low cutting time, which affects the types of vibration that occur. Then milling with a spindle speed of 120 RPM, only forced oscillation are active during the cutting time T-cut. Due to the peculiarities of change in the thickness of the cut layer during uphill milling, the indentation of the sample Bmax under the action of the cutting force is less than with the associated one. With increase in the spindle speed to 200 RPM, the cutting time decreases. In upcut milling, oscillation occur then are superposed on the forced ones. With accompanying free oscillation with period TFO, they act during the time TAO and disintegrate. After the cutter exits the cutting zone, free oscillation of the sample with a period of TAO act, which also decay. Increasing the initial cutting speed leads to increasing in the amplitude of accompanying free oscillation. Then the milling with a spindle speed of 700 RPM, this vibration are superimposed on forced vibration, both in upcut milling at the beginning of cutting and in crimp milling at the end of cutting. The occurrence of free oscillation and their attenuation during the end milling is associated with a change in thickness of the cut layer. Based on the results on the studies, the following conclusion will formulate. The regularities on the action of various types of oscillation during the cutting are determined. First, forced vibration act and accompanying free vibration on the technological system are superimposed on them. After their damping, adjustment occurs and stable self-oscillation occurs. The possibility of developing various types of oscillation depends on the cutting time. For example, then turning, then the cutting time is large, conditions arise for the action of all types of vibration. In the end milling, the cutting time limit does not allow stable self-oscillation to occur. The amplitude of accompanying free oscillation depends on the initial conditions. Therefore, as the cutting speed increases, it also increases. In further studies, it is planned to determine the effect of dynamic properties of the technology system and the amplitude of accompanying free oscillation of the cutting models and tool geometry. We express our gratitude to organizers of conference for their help in preparing published material. We express our gratitude to Professor Zaloga, Professor Stupnitsky, Professor Tankanoghi, Professor Permяков for research support. Thank you for your attention.
Hello, I'm glad to welcome all participants of the conference. Me and my colleagues Shreb Jamilov and Eskander Bekirov from the Crimean Engineering and Pedagogical University and Alpero Isal from the Yildiz Technical University would like to present a report on the topic and impact of the cutting fluid supply on contact pressures processes during drilling stainless steel. When processing body parts, drilling is performed at the final stage of the technological processes. Drilling operations are carried out when supplying lubricating coolant technological media to the cutting zone. A very important aspect is the need for a guaranteed supply of lubricant to the chip formation zone. Constant chip removal and high specific pressures in the machining zone limit the use of minimal lubrication technology. Drilling stainless steel is also accompanied with high temperature load. In the absence of sufficient cooling of the cutting zone, the tool life of high-speed steel is sharply reduced. As a result, there is significant increased the micro roughness of the machine surface. The combination of these factors leads to the need to supply a large volume of technological media when drilling holes. At the same time, most of the composition of technological media used in production are mineral oils or emulsions based on them. With prolonged exposure to the operator's body, various additives that make up such liquids lead to occupational disease. In addition, it's important to properly dispose of used process fluids, which entails additional costs. Therefore, the search for alternative environmentally friendly lubricants has become widespread, which will allow maintaining the reduced required surface quality without reducing the productivity of machining. The aim of our research was to evaluate the performance of various cutting fluids in stainless steel drilling. Experimental studies was carried out on a radial drilling machine model 2K522. The tool used was a twist drill with channel for the internal supply of cutting fluid made from high-speed steel. Drilling was carried out in stainless steel. Drilling diameter was 12 mm. The following process media were selected: water-based Aquafreeze 6, oil-based Mobimed 423 and sunflower oil. Coolant was supplied to the cutting zone through the internal channels of the tool at a working pressure of 5 bars. In view of the peculiarities of the drilling process, the most rational would be measurements using thermocouples. The thermocouple junctions were located opposite the strain gauge in 3 prepared holes with the same pitch from the end of the cylindrical billet. The depth of the hole into which the thermocouple junction was placed were calculated so that when the main hole was obtained, the distance between the junction and the generatrix wall was 250 micrometers. Temperature data were recorded as the drill bit passed against each thermocouple. As the drill went deeper, the circuit switched between each thermocouple. The data recording rate was 50 readings per second. This method does not allow estimating the actual temperature in the plastic deformation zone, but it's sufficient for estimating the qualitative effect of various technological media. Processing mode are selected according to average production indicators. Cutting speed 255 roll per minute, feet 0.06 mm per revolution. Roughness parameters after drilling were measured using a profilometer. The power characteristic of the cutting process largely determine the nature of chip formation. The effect of the influence of cutting fluid used in the machining process can be assessed precisely by the force indicators of the cutting process. The application of the method of evaluating power characteristic using strain gauges make it possible to evaluate dynamically changing indicators on parts of any configuration. As can be seen from the graphs, the use of sunflower oil as a process medium leads to a decrease in contact pressures values by more than 60% compared to mineral coolant and emulsion. A decrease in the values of contact pressures indicates a decrease in the resulting cutting force due to a change in the angle of the plane of the actual chip shear. Another characteristic of the cutting process that affects the tool life is the temperature in the cutting zone. According to the proposed method, measurements were made and the graphs we draw showing the qualitative characteristic of the applied lubricating cooling technological media for the temperature change in the contact zone. As can be seen from the graphs, the most pronounced effect of the cooling of the working area is the use of the emulsion. Due to the high pressure, heat is actively removed from the cutting zone. The use of oil lubricating cooling technological media leads to an almost twofold increase in temperature compared to the emulsion. The nature of the graphs indicates the actual temperature in the cutting zone is above 250 Celsius degrees, which exceeds the smoke point of these oils. At such a temperature and high specific pressures, the destruction of carbon chains occurs. The main characteristic of the drilling process is the quality of the resulting hole. In the study, as a parameter of quality, the control of the roughness of the resulting surface was carried out. A significant decrease in the roughness index when using sunflower oil can be explained by the presence of polar molecules in the composition of fatty acids present in the oil. Polar molecules, due to the odor arrangement, create a film of the structure of the tool and workpiece, which help to reduce frictions. Due to the high values of chemosorption of polar molecules, the elastic plastic contact zone shifts towards the cutting edge due to the Rebender effect. As a result, there is a decrease in the cutting in the zone of plastic contact and change in the nature of build-up formation. This leads to a change in the geometry of the rake angle of the tool. Increase the rake angle values change the position of the actual chip cut plane. All these factors contribute to the facilitation of the chip formation processes and as a result to a decrease in the roughness value. Based on the data obtained, the following conclusion can be drawn. The most significant effect was obtained from the use of sunflower oil as a cutting fluid. Due to the presence in the composition of fatty acid having a polar molecular structure, a decrease in roughness is observed after processing. This is due to the change the angle of actual shear plane. In this case, a decrease in contact pressure indicates a significant decrease in the resulting cutting force. Vegetable oils have a low smoke point, like mineral oils. However, due to degradation, thermal and mechanical, sunflower oil fatty acids from free radicals that passivate juvenile surfaces. Thereby reducing surface energy and facilitating the cutting processes due to the Rebender effect. And further study it's planned to evaluate the influence of various technological media on the power characteristic of the cutting zone. Contact pressures, temperature and vibration of the system is one path of the tool in order to optimize the processing modes for specific conditions. I want to express my gratitude to all the organizers the conference who, despite all the difficulties contained, remain the high level of the conference. Thank you for your attention.
Good afternoon, everyone, and welcome to my presentation. First of all, let me thank you all for coming here today. Let me start by saying a few words about my work. As you can see on the screen, our topic is load parameters of the gear machine by power scaling and their influence on the machine system. In recent years, of power scaling method, formerly known as a gear turning, has been widely used to produce spur and helical gears for internal or external gearing, as well as spline surfaces. The requirement used is both universal multi-purpose 5-axis CNC machines and specialist gear mill machines. Positive features of this process include higher chip removal rates, no idle strokes, and short machine times, as well as the ability to combine it with other shaping methods is one operation on CNC machine. Due to the latest technological developments, is particular achievement in the field of machine tool engineering, the software, and tool production. This technology has become flexible and efficient, as well as an alternative to traditional gear cutting method, with an expansion of the range of cut wheel up to module of 10 millimeters. The feature of the power skewing method are significant forces and moments on the axis of the tool and workpiece combined with higher cutting speed. To achieve higher machine accuracy, significant machine rigidity is required, as well as high level of synchronization of tool and workpiece rotation. Failure to meet these requirements lead to increases vibration and gear profile error. You can see the workpieces and tool or cutter. So the main aim of our research is cutting force is one of the main physical parameters characterizing the cutting process. Elastic strains and vibration, machine accuracy and surface roughness, machine tools durability, cutting tool life, machine performance, and energy consumption depend on this force. The importance of cutting forces increases in multi-tools cutting when the load on the system is the result of a combination of elementary forces that occur on separate teeth and tool blades. The complexity of the modeling the cutting forces increases for processes that are considered continuous and that occur during the continuous rolling of the tool and workpiece, such as power skewing, as well as hobbing, hot scouting, and grinding gear with diamond hobbing wheel. So, in this work, we use the following logical research scheme based on the basic or classical organization of cutting theory. Analysis of kinematic schemes of the process. First of all, we must chip modeling, chip cross-section parameters, and next step is intensity of shear and contact deformation on the surface. Next step, single or elementary cutting force on the edges. Total cut after that, total cutting force on all simultaneously working teeth. And after that, at the end, fluctuations of the cutting force in a continuous cutting cycle. This data can then be used to solve various problems that arise in the design of machine process, predicting machine accuracy, friction, and heat flows, tool temperature and wear, vibration of the machine elastic system, as well as improving the tool geometry and selecting appropriate protective coatings. This approach ensures comprehensible and systematic research. First of all, we must to see this process kinematics. In power skewing, the main cutting motion is the rotation of the cutter combined with the moment of the cutter along the workpiece's axis for spur gear, which causes by the titles of the axis: auxiliary motion and auxiliary feed rate F of the tool and the circular feed rate of the workpiece. In this picture, you can see all these vectors of velocity of V gear, V instrument or cutter, and V summer, V is the speed of the resulting cutting motion. According to this scheme, the tool's trajectory is the geometric sum of the vector of rotational move around the tool's axis and the straight line motion along the wheel axis in the actual feed. So the first step, we must create a 3D model of an underdeformed chip. We use technique similar to that in our work early. This technology developed for worm gear milling. Involved represented a continuous cutting motion during the rolling process by sequence of decreased cuts. So you can see 3D model and deformed chip form initial date. Model M 5 mm, actual feed rate F equal 0.5 mm over where the number of the wheel teeth equal 33 and number of the cutter teeth 24. After calculate with single pass cutting, the cut parameters are larger and thus significant cutting force and elastic deformation will occur. As a result, in practical, multi-pass cutting is used to reduce these parameters and to compensate for the time lost. Machining is performed at night in higher cutting speeds. Adoption of the developed methodology to the conditions of multi-pass gear cutting made it possible to model chips and their parameters when cutting in the 3 passes. Cross section, you can see on this figure cutting thickness for first pass, for second pass, and third pass, and cross section area for first, second, and third pass. And we must calculate it cutting compressive ratio. So our result. Let's define the component of the cutting force that coincides with the cutting speed vector and is commonly referred to in cutting theory as a main component. In this feature, you can see how many force Newton, and we calculated the force R. We turn to the shear force P tau, and magnitude of the force is determined by the shear area S and the shear strength of the materials. After that, we definitional and determine friction force. According to the definition of R force, its direction coincide with the cutting speed vectors. The conditions of intense oblique cutting, especially at the small angle of inclination of the tool's teeth, cause significant friction and from the surface during chip flow. The direction of friction on the leading blade coincides with the cutting speed, while on the output blade it acts of the opposite direction. And after that, we calculate torque Q and taking into the account the value of the angle between axis of the tool and gear workpieces from 15 degree to 45 degree. It can be noted that with an increase in this angle, the torque acting on the axis of the workpiece decreases, but the actual load in the direction of actual fit on the machine components increase. The torque on the tool's axis remains unchanged. So, as follows from the result obtained under the influence of period factors, the maximal torque value acting on the axle on the cutter and the tool's spindle of the machining in the direction of rotation of the workpiece is 54 Newton multiplied meter, and in the opposite direction 42. The range is 94 Newton multiplied meter, and the average torque value is 4. Such data indicates that in this process, cycle load with alternative signs pose the greatest danger. This disturbance can lead to significant error in gear machining due to insufficient torsional rigidity of the machine tools and loss of synchronization in this moment. And some conclusion. A system for computer modeling the parameters of the gear cutting process using the power skiving method has been developed. This system is based on a 3-dimensional model on undeformed chips and make it possible to calculate and predict the power factors of this process, cutting force, its components, and target. In multi-pass cutting, the thickness of the cut on the blade is small. The value on the minimum radius depending on the cutting condition can be determined using the method described in this work. Two facts have the greatest influence on the cutting force: the cross-section area of cut and thickness of the cut. According to with straight side blades and a sharp blade edge with a positive front angle is sufficient for the roughness pass, as the shape of the tooth face does not affect the accuracy at this stage. Thank you for your attention.
Dear colleagues, my name is Yulia Lashina. I am an associate professor at the Department of Manufacturing Engineering of Igor Sikorsky Kyiv Polytechnic Institute, and it's my pleasure to make a presentation on the topic Integrated Process Model for Development and Manufacturing of Customized Orthopedic Implants. The use of customized orthopedic implants is highly desirable in many cases and offers significant advantages in terms of patient treatment. However, the widespread use of individual orthopedic implants has been limited due to various reasons until recently. Firstly, there have been insufficient technological capabilities of the available equipment. Secondly, there has been a lack of understanding of the features and interconnection of all stages of production process planning and manufacturing of parts. These limitations have resulted in an increase in the time and cost required to manufacture such products. With the emergence and development of additive technologies, their popularity in the field of biomedicine has been growing rapidly. From a practical standpoint, information management and manufacturing of products with high degree of uniqueness are two critical tasks related to the use of additive manufacturing in orthopedic. The production of individual orthopedic implants is a technically complex task that involves processing a wide range of information. Increasing the degree of customization can improve the reliability of surgery, while also reducing the duration and overall cost of treatment. However, this degree of customization adds a high level of complexity and variability to the product, which in turn complicates the processes of design and manufacturing process planning. Two critical tasks in this regard are resource planning during individual implant production and process and data modeling. The process of design and manufacturing are an integral part of the value chain. Therefore, a business process model can serve as a basis for managing product development and optimizing production processes. Several methods are available for modeling business processes, and among the most popular today is the business process model and notation system. This system represents business processes through diagrams that use a basic set of elements to describe complex semantic constructs, work operations, key participants and performance, as well as data flow, including those occurring in the additive manufacturing process, could be integrated into a unified system using BPMN, making it an effective tool for process modeling. To the best of our knowledge, there is currently no comprehensive model available for the process of developing a customized implant from the initial patient contact to the delivery of the final product. The expected impact of the study is to reduce the production time of custom orthopedic implants through rational resource planning and the elimination of unnecessary iterations, and as a result, their cost reduction. The objective of this study is to examine and evaluate the various stage components and parameters involved in the development and manufacturing of customized implants using additive technologies. The aim is development of a comprehensive computer-integrated model to optimize the entire process in terms of time and cost, from the initial data preparation to the start of surgery. To accomplish this goal, the following tasks should be completed: review and analysis of existing practices for implementing the production process, evaluation of the various stage components and parameters involved in the development and manufacturing of customized implants using additive manufacturing, selection of a suitable business process modeling methodology, identification of key factors that affect resource consumption during the production process, investigation of the nature of interrelationships between main processes. Since the study covers different aspects of the production process, from customer contact to shipment of the packaged product, the decision was made to use the BPM and business process modeling methodology. The product development and manufacturing process can be represented in 5 consecutive stages, containing initial data, reverse engineering, modeling, prototyping, and manufacturing. At each stage, specific business roles perform certain tasks and interact by exchanging data and prototyping manufacturing results with one another. The process involves 3 key business roles: medical service, development, and manufacturing. The resources required to realize the production of custom implant have been categorized into 3 groups: human resources, information resources, and material resources. So the amount of use and the cost per unit of amount are the characteristics attributed to each resource. The total cost of resource usage is calculated as the product of resource amount and resource rate. Human resources. This study focuses on the critical specialists responsible for carrying out medical, development, and manufacturing tasks. Resources needed for support processes such as project management, accounting, and supply chain management are not considered as a part of this study. Informational resources can be categorized into three distinct groups: software, knowledge, and computing. Specifically, the study examined the necessary informational resources for two categories, namely development and manufacturing. Material resources considered in this category are the following types of the resources: equipment and materials. So, the study aims to explore content characteristics, impact, and limitations of the aforementioned elements. The final focus will be on identifying the time characteristics by utilizing the objective function of minimizing the cycle of development and manufacturing of a customized implant prior to the surgical operation. Additionally, the study seeks to determine the cost components and their corresponding amounts. So let's define the tasks and characteristics of the business roles at each stage. Obtaining initial data commences with a visit by the patient to a medical facility. The medical advice provided entails analyzing the patient's health status, prescribing any necessary medical tests such as computer tomography, magnetic resonance imaging, and carrying out the required test. Subsequently, the need for a custom implant is evaluated, and if such a need exists, a request, together with initial data comprising a set of CT MRI scans, is sent to an organization responsible for development and manufacturing of a custom implant. So the development stage begins with the acquisition of the CT MRI scans. On the right, we can see the required human and material resources to complete this stage, as well as calculated time and cost of resource usage. Stage 2 begins with the creation of a virtual model of an anatomical object through processing a set of images gathered via CT MRI diagnostics. The next task entails producing a full-scale model utilizing the STL file obtained in the previous step as input data. The full-scale model is created through the utilization of additive technologies such as, for example, FDM. Subsequently, the final product is transferred to the medical institution. For a medical institution, the first task of the second stage involves obtaining this full-scale model, followed by the task of planning the surgical procedure while preparing the product requirements document. This stage is crucial for the development of a customized implant as it involves the preparation of all necessary input data. The stage concludes with the transfer of the planning results for the development contractor in the form of a full-scale model marked with appropriate attachment sites and the product requirements document for the customized implant. The required resources are presented here and include all resources needed to complete all these three tasks, as well as stage completion time and cost of resource usage. Stage 3 design begins after the initial data is received from the medical institution. In addition to the digital model of the anatomical object and the product requirements document, the design must also consider the constraints and specifications of the manufacturing process. In order to obtain this information, the executor of the development process is required to send a request to prospective manufacturers. The executor of the manufacturing process processes the request, prepare a proposal, and send it to the developer. So the executor of the development process receives manufacturing data and begins the tasks associated with the development of customized implant. This development involves using a database of standard solutions and design guidelines. So the result of this step is a comprehensive implant model that will be used for prototyping and medical validation, a computational model optimized for finite element calculations, and additive manufacturing model, which may contain the necessary elements for subtractive machining and allowances for cutting. A model of surgical guide is being developed simultaneously. The integral resources required to complete this task are presented on the right, as well as stage completion time and cost of resource usage. Stage 4 prototyping begins with the additive manufacturing of the implant and the surgical guide prototypes utilizing one of the available additive manufacturing technologies. The resulting prototypes are subsequently transferred to the medical institution for validation. The medical institution receives the models, performs the simulation of the surgical procedure, and analyzes the results. Depending on the simulation result, there are two potential scenarios for the subsequent course of the process. If the simulation results are not satisfactory, there is a need to modify the design. The medical institution will communicate its recommended change to the developer. The developer makes change to the model, reprints it, and submits it for revalidation. If the simulation results is satisfactory, in this case, doctor will provide a physician's information and the technical specifications of the designed product. Subsequently, the next stage of process commences. The result of this step is custom implant prescription. Integral characteristics of this stage are presented on the right, including resources required to complete all tasks and including possible need for changing models, as well as stage completion time and cost of resource usage. 5. Manufacturing of a customized implant begins with the transfer of models and the product requirements to the manufacturer. The manufacturer validates the models and approves the product requirements document. Following this, an evaluation report is sent to the developer. The report includes the results of the analysis, which may indicate any necessary design change that should be implemented. The developer analyzes the manufacturer's recommendation and, if needed, makes change to the design that are approved by a medical institution. In the event the change are requested to the design, the medical institution provides authorization for proposed modifications. If the results of model validation are successful, the manufacturer proceeds to the development of a process plan for the customized implant. The fabrication process initiates with the additive manufacturing of the component, encompassing tasks such as the development, the control program, machine setup, additive build, the post-processing operations, and so on. Subsequently, the fabricated component is assessed for conformance with the technical specification and, if it meets the requirements, proceeds to the next stage. Following the established manufacturing process, control programs for CNC machines are prepared and subtractive operations are implemented. These operations may include milling, drilling, grinding, and so on. The machined component is inspected for adherence to the technical specifications and, if compliant, advances to the next phase. Upon completion of cutting, the component undergoes a cleaning task, coating operations. Subsequently, the sterilization of the product may be performed either by the manufacturer or the medical institution. At the final stage, the product is packed and sent either to developer or medical institution. Integral characteristics of the manufacturing step are presented on the left and include all required resources, as well as stage completion time and cost of resource usage. The study has therefore identified the primary resources that directly impact the time required to manufacture a customized implant, from the initial patient request through to the delivery of the final product to the medical facility. The optimization of the development and manufacturing process can be aimed at two objectives: minimizing time and minimizing cost. The selected BPMN method allows to present thoroughly the main stage of creating custom implants, key processes, key business roles and their interaction. The developed model comprises the key resources necessary for the implementation of each stage, which determine the cost and duration of the processes. And therefore, the optimization problem can be formulated. The limitation of the developed model is that it does not fully take into account the implementation of the quality control and assurance system. So future improvement of the model is possible in supplementing it with the additional resources, information and human, as well as processes related to the quality management. In addition, the model can be further advanced for parallel development and production of several different custom implants. So within this study, a computer-integrated model for creating customized implants using additive technology, which employs the PPMN system for modeling the business process, was developed. Main conclusions are presented on this slide. I will not read them. Thank you for your attention.
So, hello colleagues, you are presented with a report on flow, follow and round calibers roles of high-speed wire block. Wire rod is one of the most important and popular types of phone products from the point of the view of the breed of the circle consumers. Wire rod is a universal type of metal product. According to the OECD, its share in all long products produced worldwide is about 12%. Economical productivity and technological billet enter speed in the first end of a continuous mill are why wire rod must be rolled at high speed. The rolling speed in the finishing pass on modern continuous mill is more than 100 meters per second. For the smallest wire rod diameters of 5 to 6.5 millimeters. There is intensive wear of the calibers because of high rolling speeds in the last passes. The normative durability of caliber hard alloy rolls of wire finishing block is 1,200 to 1,400 tons or 16th to 18th hours of continuous operation. The actual durability can be 700 to 800 ton due to the particular of operation. One major factor that adversely affects the stripe's quality during hot rolling is roll wear. Improving roll's lifespan in hot rolling process is of primary concern for metal forming industries. Replacement and early breaking represents 15% of the production costs. In reality, the cross-section of a rod with perfection roundness does not exist. This is called ovality, calculated as subtracted length of the short axis from the long axis of cross-section. In rod mill, ovality is usually in range of 0 to 0.4 millimeters. The wear on roll is the biggest obstacle for us to have zero ovality. This work aims at designing of method for studying fair rolls of the wire block mill. Typically, caliber wear is measured using a clock indicator. Its accuracy is plus minus 0.01 millimeters. We must say that other methods and devices for the experimental study of wear were also published in the technical literature. The characteristic of roll grooves wire block is that they have relatively small cross-section. In this case, the clock indicator succeeds measuring only in the middle of the caliber. Research shows that in same cases maximum VO exists aside from the center of the roll groove. There is a problem with starting VO of caliber on all white it cross-section in this condition. For study VO of caliber on all it white achieved by developing optical and light method of studying roll grooves and by creation special measuring device. The optical and light stand was used as measurement device. Example in this picture. Stand include an illuminate, magnifying lenses, a screen, and a camera for fixing pictures. During the study, the roll were put between illuminant and magnifying lenses on distance focus. Then the template is put inside the rolling groove and the special device strictly fixes its position. The larger image of the gap between the template and the roll groove arises on the stand's screen when the light turn on. On these photos and next photos, we can see a gap between thread bar caliber and template for the 10 stands of wire block and micro relief surface thrown out rolls are in. In this photo, first 5 calibers, and in these photos, next 5 calibers, finished calibers. Sizes gaps and on specific parts of cross-section of calibers are shown with figures on photos. We noticed that rolls of the first 7 stands of wire block have 2 identical calibers. Each roll in the rest 3 stands have 4 calibers. Only 1 caliber in the first 7 stand was used during the research, and 2 calibers was used during the research. There are conditions of deformation caliber sizes, mean pressure and separating force at the stands of the wire block. In the table on this picture, we estimate precision measuring VO rolls using an optical light stand compared to clock indicator readings before analyzing research results, which are given in pictures on previous slides. In the same measurements of VO grooves, caliber after 2 methods produced campaign work rolls. In both cases, measurements were performed at the center of the groove's caliber. There are results measurement of VO rolls in all stands of wire block in this table and the next table. Statistical analysis of the data was obtained. To do this, the t-statistics checks whether the sample from one offset in table 2 belongs to the other in table 3. Critical value with reliability of P 0.99 and degrees of freedom 102 is 2.62. Comparing the calculated and critical values, we conclude that with high reliability, measurements made using an optical light stand do not differ significantly from readings of clock indicators. We obtain similar results when both samples. Dispersion was compared using the Fisher criterion. It must also note that the reading of the optical light stand checked for normal distribution, and the correspondence to the Gaussian curve was established. In this slide we can see results measurements of caliber rose by clock indicators in millimeters. And now we analyze the results of measurement rows shown in previous figure and table 4. It received at conditions given in table 1. As can see, there is almost equable value of calibers from 0.2 millimeters to 0.3 millimeters in the first 3 stands. A Brazil value is evident, especially on the surface grooves rolls of the first 2 stands. There is an initial thermal grid on the surface of the thread bar groove rolls of these stands. There is an abrupt transition from a smooth surface to a rough on one with outlines of alternate protrusions and depressions on the rolls of the second stand, which is associated with incomplete caliber filling. The rolls of the fourth stands have intense wear along the bottom of the caliber. The most significant wear of the surface rolls is observed in the fifth stand, which is 0.5 to 0.6 millimeters. Although the surface remains smooth, there is practically no spotty. The micro relief is degraded near the gaps of the caliber. Significant wear of the surface of the rolls of the fifth stand is associated with a significant wind pressure of the metal on the roll in this path, and the slide of the metal in the deformation zone. In the sixth stand, the minimum wear is located near the top of the caliber on either side. The maximum wear of the rolls of this stand is observed along the diagonal of the caliber and amount to 0.25 to 0.27 millimeters, which indicated the tipping of the bar in the given the wear grooves around dual calibers in the finished wire block are visibly affected by the console position of the rolls and the use of fluid bearing for their supports. This design peculiarly leads to the skewness of the rolls in the bearing and the roll axis deformation under the rolling loss influence, like this we can see on this picture. As a result, the shape of the calibers and billets for all models becomes asymmetric. Templates of oval profiles after rolling in finishing bond calibers shown in this picture, which most clearly illustrate the asymmetry of the process. This leads to loop-side reduction and 4-section metal to the rolls in the width of each grooves. The location of the rolls at an angle of 45 degrees to the horizon leads to the fact that during rolling a slightly larger amount of water enters the deformation zone from the side of the lower grooves under the action of gravity with cools the equipment of the finishing block. Water entering the deformation zone instantly turns into steam, which is compressed between the billets, hot metal, and the pass cold surface, causing extreme destruction to the lava grooves roll. Thus, the design characteristic of the models in wire block leads to asymmetric world of grooves of round and oval calibers. The subsequent analysis aims to elaborate a statistical model for the view of carbide rolls with oval and round bases for hot rolling wire rods based on the analysis of the character of water of oval and round calibers of the high-speed finishing block with cantilevered rolls. It is necessary to consider the symmetry of the rolling process associated with the design particularities of the equipment. This paper proposes a view model of an oval caliber consists of 4 parts. First, upper roll drive side, second, upper roll empty side, third, lower roll drive side, and fourth, lower roll empty side. The formulas for calculating the value of wear grooves carbide rolls were obtained on the result of the analysis by the method of multiple nonlinear regression after choosing the most appropriate type of model for each part of the oval and round caliber. On this picture, models for oval caliber and this picture model for round caliber for all parts of the caliber. Research showed that the maximum depth of calibers is unevenly distributed at stands of wire block when the rolling wheel is 5.5 millimeters in diameter. The fourth and fifth stands where abrasive wear prevails are most susceptible to wear. The non-linear regression formulas for calculating the values wear grooves carbide rolls were obtained. It is proposed to consider a wear model of an oval caliber consisting of 4 parts for modeling character wears near the actual process. As can be seen from the statistical analysis results, the wear of oval and round calibers depends on the length contact line, decreased rolling speed of the metal round strips, and the entrance to the deformation zone of oval calibers, which corresponds to increased sliding, leads to an increase in wear. For all wear models obtained, it is characteristic that an increase in dimensionless parameters M3 leads to reduction in wear. This relationship is explained by the fact that grows the parameter M3 occur due to a decrease in the rolling force and with conditionally constant quantity of metal per roll campaign. The models can be used in practice to develop material saving technologies for rolling wire rods on modern high-speed rolling mills. Thank you for your attention.
One minute and we will continue. Just a second, we need some technical issue to fix. Okay. Dear participants, thank you very much for your patience. Thank you very much for well-prepared and well-presented presentations. It was nice to see the recent research results from different institutions and different countries. Now we can discuss the presented research results, and also you can ask questions. You can ask your question raising your hand and use your voice to ask a question. Also, you can use the chat menu, so you can write your question and participants will see it. Also, I can announce it. So the first presentation was presented by Natalia Balecka from Zhytomyr Polytechnic State Institute. It was the title, The Multifractal Analysis of Periodic Surface Relief of Parts and Phase Milling. Natalia is now in the chat and she will be ready to answer your questions. Any questions to Natalia? Okay, maybe I will ask a question.
Yeah, you're welcome.
It's nice to see you, Natalia.
Good afternoon, all participants and host of conference. It's nice to see you all.
Thank you. Greetings from Sumy State University, and I would like to ask a question.
Yeah.
My question is the following. Is it possible to use the presented approach to other machining processes? For example, turning, grinding, boring, drilling?
Yes, of course, it's possible. Thank you for your question. And the problem is a difference in surface, because we try to apply a multifractal analysis to describe surface after phase milling. And in this case, we had surface with strong regularity. Yes, in case of grinding, we have non-regular surface, and it is easy to apply this method to describe surface after grinding. But after cutting, it is different and it is most complicated. So we are only in beginning on our way. Yes, and I hope that soon we will have more results in this case.
Thank you very much for your answer. Thank you very much for your contribution. And I would like to say that the full text paper was published in the book, so you can have an access to this book and you can read more about this approach. Thank you very much, Natalia.
Thank you.
Okay, as I can see, there are no questions to Natalia, so we can go to the next presentation. Presentation 2 was presented by Yuri Hazanovich, and I didn't see Yuri now in the chat. So we can skip it and go to the third presentation. The third presentation was regularities of oscillations during turning and milling. The presentation was presented by Pavel Trishin, and he represents the team of researchers from National University Zaporizhia Polytechnic. And also I can see the other authors of this presentation, Professor Vnukov and colleagues Sergei Dyadya from the same institution. So any questions to our authors? No question. Okay, maybe I will ask a question. Pavel, my question is the following. In the presentation, you presented a device for studying vibrations during turning. Is it a novel design? Is it patented?
This device is patented. It's no new device or construction.
Okay, so it's your idea and your implementation and your development of this device.
it's idea of all of authors.
Okay.
Not only I.
Okay. Thank you very much for your presentation. Maybe someone wants to ask question. No questions. Okay. Let's move to the next presentation. Next presentation was presented by Ruslan Jamaluddinov, but I didn't see him and his co-authors in the chat. So presentation 5, also there is no authors. There is no opportunity to ask questions them. Presentation number 6. It's interesting presentation, in my opinion. It is interdisciplinary research, and engineering and medical aspects was researched. And I'm happy that the authors, Professor Pasechnik and Dr. Lashina, presenting now in the chat. Thank you very much for your participation.
Thank you, dear colleagues, and best wishes for us participants of the conference.
Thank you very much. Natalia, yes, you can ask a question.
I would like to ask, maybe my question is not related to today's topic, yes, but I'm interested in which material do you use to manufacture implants? It's shape memory alloys or not? Material for implants.
For real customized implant uses the titanium alloys, but for feature for supporting of the process, we use different technologies of FDM, LCD, and other technologies for making fixtures from plastic and other materials. This technology use a complex of the materials and specialist. No, we not use materials with memory, but our each solution is for individual patient using. And main goals of this decision are understanding all elements of complex process, and after used for minimizing time of all process. In some situation, time may be critical parameter. For example, cancer. You not need many times for reaction. We may prepare to surgical operation in shortest time. And now we have the system. We have understanding of each element from initial stage of CRT MRT to start of the surgical operation.
Okay, thank you. So you don't work with nitinols, yes? Nickel titanium alloys. It's shape memory materials, and it is.
No,
no.
Our system can be integrate any newest material.
Okay.
But we can describe a specific of this material and integrate to the information system for next model.
Okay, thank you for your answer.
Thank you, and you.
Thank you very much for answer. Thank you very much for your question. And I'm moving to the last presentation in this session, presentation number 7, where and oval and round calibers roles of high-speed wire block. This presentation was presented by Maxim Stoda from Metinvest Polytechnic, Technical University. Any questions to our participants? He is now in the chat. It seems it was very clear and understandable. Thank you very much, Maxim, for your participation. Thank you very much for your paper, for your participation and contribution to the book. Okay, so I would like to sum up that we are in timely manner, and the General Chair asked us to be in time, and we complete this session as scheduled. Thank you very much. I would like to remind that tomorrow we will continue the conference. It will be 4 sessions starting at 10 a.m. And also you can join us using the same link. And session number 4 will be focused on design, engineering, and production planning. Session 5 will be focused on advanced materials. Session 6, mechanical engineering issues. And session 7, quality assurance. I invite you to join us tomorrow to learn more, to ask your questions, to be active in discussions. Thank you very much. It was a nice pleasure to see all of you. And see you tomorrow. Slava Ukraini!
Героям слава!